अब दिख रहा है?
Perfect.
Okay. So yeah, how do you want to have any introductions, or should I just start?
No, I think Omkar, what would be helpful is यदि students का एक बार expectation set कर दें,
Hmm.
if we tell the students what they can expect, तो I definitely want to tell students, guys, मैं आप लोग को एक चीज बहुत clearly बता देना चाहता हूँ. I want to tell one thing very very clearly. You would suddenly find out कि physics को इस तरह से पढ़ाया नहीं जाता है. तो ऐसा हो सकता है that you might you might think that when are we going to start solving problems? We will get there, but not immediately. So over to you, Omkar. If you can tell us how we'll do this class, that would be great, and then we can jump right into it.
Yeah, so in fact, the whole point of this introductory class is to outline how we are going to study the subject, because that is so let me put the agenda here. Okay, so the agenda for today is to answer these three questions. What is physics? So the what question, the why question, and the how question. So that will be the focus today. We are not going to get into the nitty-gritty details of the subject today, but I will lay out a roadmap and explain the high-level philosophy of education that we are going to follow, so that next time onwards we can start, or if there is time today, towards the end of today's session, we could start following that approach, and it will take us a few weeks before we can actually uh, start solving problems that will look familiar to you. Because uh, the fact is that physics is, in my opinion, not taught in the right way. There's a lot of background context that needs to be established before you can truly embark on the subject, and that context is missing from your textbooks. So my goal is to establish that context in the first few weeks, so that when you get into the meat of the subject, you have a very clear understanding of, why are we studying motion? Why are we studying, um, why are we defining energy in this way? Why should a quantity called work be defined? Um, None of those questions can be answered without that background context. So, do you want me to elaborate on that, Kapil, or should I just proceed with this agenda? Because
No,
I'm
no, proceed
hoping
with
that
this.
the
Proceed with this. Proceed with
okay,
this.
because I think this itself will uh, convey how what we are doing is different from what they are used to. All right, so first, let's look at the superficial answers to these questions, and then I will give you the deeper answers. So, what is the superficial answer to what is physics? So, by the way, couple, do they get to answer or type in their responses in the chat window or Q&A window, or how should we
Yeah, I
proceed
think
with the
they
Q&A?
can write in the chat window because there are a lot of students live right now. So if everyone starts speaking, it can become very noisy.
Right. So they would type it in.
They can type it in and we can see the chat. Guys, can you type in the chat in your mind what is physics?
So I'll give you the superficial answer. Um, you already have been, I assume many of you have been looking at your physics textbooks. You've gone through some of the curriculum yourself. Um, one way to answer it is to say, well, it's a list of topics like mechanics, thermodynamics, optics, electromagnetism, modern physics, and so on. But these are just examples of topics. Okay. It doesn't explain what physics is and why these topics are a part of physics and how physics differs from other sciences. Okay, so the deeper answer to the question would have to would have to deal with those with these issues. Okay, what makes all of these topics part of physics? How does physics differ from other sciences? Secondly, why should I study it? Okay, I'm seeing a good set of responses, um, and some of you have captured the general answer, but I'll be a little more specific. Okay, second question, why should I study it? To clear NEET or whatever entrance exam. I'm seeing some of the answers already there. So that's again a superficial answer. It's an important answer. Okay, it's required for your entrance exams, and exams are practically important for your career and all. But if that's your only motivation, then there is a risk that you're not going to enjoy the experience of learning physics. It will become possibly boring and burdensome, given that this is a long journey. Okay. So your school, your 11th, 12th grade is actually not the end of your education, it's the beginning of your education. Even if you, even after you get into a good college, you will find that you will be competing. You will have lots of exams there also. You'll be competing for many more years with even more, with an even more selective group of peers. Right? Right now you're competing with uh, the whole, students across the whole country, and many of those students may not make through the entrance exam, right? So the average quality of the student right now that you're competing with is lower. But after you get into a good college, that bar will increase. So if exams are your only motivation to study your subjects, then you might have a burnout. And I've seen
Omkar,
that,
can you make me co-host some? Probably, I'll just manage the crowd with respect to uh,
right.
the sound that is coming. Anurag, Kashish, if you want it only in Hindi, आप यहाँ से जा सकते हैं. It will not be in Hindi because there are a lot of students from South as well, and the assumption is that everyone would be able to understand English. If आपको problem हो रही है तो आप यहाँ से जा सकते हैं, कशिश और अनुराग, and you can watch it later. है ना? Don't waste your time if you want it in Hindi.
I made you the co-host, Kapil.
Okay, yeah.
Okay.
Omkar, I muted you as well, so just be careful.
Okay. So good exam performance should ideally be a side effect of enjoyable learning, right? So your journey of preparing should have value irrespective of the exam results. Only then will you be able to sustain this for many more years and even increase your probability of getting good results for the exams that you're preparing for. Okay, so that's why entrance studying physics purely for entrance exams is um, a superficial reason to study it. And
So
we'll get
Omkar,
into
tell
the
me
deep.
this thing.
Hmm.
You got a crazy rank 17 in JEE, right? Rank 17 in JEE could be as big as it can get, right?
Mhm.
So, were you enjoying subject at that point of time? You would have scored the best in everything. After that, you did very well at IIT as well. You were
Mhm.
ranked 2 in IIT in the final year. Then you went to Stanford. When did you start enjoying subject, or you also went through the same thing like a lot of these students are answering that हमें नीट का तैयारी करना है, right?
Mhm.
Or physics answer is the world around you, right? Or
Mhm.
some people are writing the chapter names. So when did you get out of this trap?
So I developed an interest in biology in ninth grade, which was related to my interest in bird watching. So bird watching is what sparked my interest in biology, which broadened into, an interest in science in general. Uh, I didn't get out of this trap for math. I got out of this trap for biology pretty early on because my motivation was not to become a doctor, but I still wanted to understand biology to expand my understanding of, not just ornithology, but evolution, ecology, and, some of those other areas. Uh, Physics and chemistry are subjects that I tried to develop an interest in. So I I didn't have good teachers in either of these subjects, but I tried to look at textbooks from outside that were not exam oriented. And I'm not saying exam prep was not part of my life. Obviously it was, but like I said, I was not interested in competitions because it just made me feel the process was too burdensome to constantly be thinking of, how am I doing in this exam or that exam, comparing myself to others. That's not, I realized quite quickly that it's not going to sustain me. And so it became important to figure out ways of learning the subject that would make me better, that would increase the probability of my doing well in the exam, but which would, on a daily basis, give me some level of satisfaction and enjoyment that could act as a fuel. Because this is a marathon, right? If you run out of fuel early on, then um, you'll just burn out. So I will, when I elaborate on the deeper answers, I will, get into more specifics there, and hopefully that should give you a more complete picture. Coming to the third question, how should we study physics? Here's the superficial approach. Attend your coaching classes or tuitions that teach you the tricks and patterns that are needed in the exams. Okay, so the emphasis there would be on memorization of formulas so that you can apply them quickly in whatever exam you're preparing for. So this kind of uh, jugaad is fine. Okay, it can be very useful when time is short. Okay, so when time is short, I would say you have no other option, right? But when you do have time, and that's my assumption here, that the students who are going to benefit from this class are the ones who have the time and who are willing to put in extra time to learn the subject in a slightly different way, in a way that has value beyond the exam. So the problem with this, the coaching center and the tuition model is that they focus less on conceptual understanding. One of the problems is that they focus less on conceptual understanding because time is short. But if you want to solve more challenging problems, you do need conceptual understanding. And the problem with developing conceptual understanding is that it needs time. So if you think about how long it took for humans to develop all the physics, actually just think of mechanics. How long did it take for humanity to develop Newtonian mechanics? It took more than 2000 years for the best minds across the world to build Newtonian mechanics. And you are expected to conceptually understand it um, in a few weeks or a few months. So if you have difficulty there, it is not a reason to feel guilty. There's nothing wrong with you. Um, but you need to spend time under the right guidance to change the way you think. The fact is that science is hard, the concepts in science are hard to understand because they actually go against our common sense. They are not common. If they were aligned with common sense, people would have invented science long ago. The reason why it has taken so much time is you have to give up your common sense, and giving up common sense is not easy because you need something to replace it, and you need good reasons to replace it by something counterintuitive. So understanding what is the problem with our common sense worldview, and building up a new worldview that is counterintuitive, that needs time. That is where the conceptual understanding comes from, and that needs time and it needs the right guidance. The other thing is, when when you focus purely on exam prep, you are mostly solving exercises. Right? Exercises are problems where if you, as soon as you read the question, the method or the answer should immediately come to your mind. ज़्यादा सोचने की ज़रूरत नहीं है. The answer should immediately come because you have very little time to solve each question. So you need that fluency, and that fluency comes from repetition and practice, which the coaching institutes, they provide a lot of that. So that part is it does increase your fluency. One issue there though is that it can become quite boring and reduce your motivation, because if things become very repetitive, then and if your motivation dips, then again you will not enjoy it, you will not be able to sustain it. Okay, so remember that your learning needs to be a lifelong activity, because you will need to continually learn even after you enter your medical college or engineering college. वहाँ तो और भी ज़्यादा complicated होगी पढ़ाई. You'll be studying more advanced subjects with a more qualified set of peers. So um, it's important to enjoy it. You have to seek teachers who make you enjoy learning. So Kapil was asking, what did I do? I tried to find teachers who could make me enjoy learning, and if there were no live teachers, then I would look at textbooks written by different authors, trying to evaluate, which author makes it more interesting for me. Um, and at the end of the day, in my experience, a, a teacher who lacks love and interest in the subject cannot develop that love and interest in the subject in you. Okay, you can only give to your students that which you have yourself. If you don't have conceptual understanding yourself, you can't transmit that conceptual understanding to students. If you don't have a love and passion for the subject yourself, you cannot transmit that love and passion to your students. So finding the right teacher, um, you know, searching for, now there are a lot of videos online, so you might be able to access a wider range of teachers and seeing who fits your, um, who is a good fit for you. Those are things you have to actively try, and that's what I did throughout my education. I was never satisfied with just the professor or teacher I got, or with just the textbook that I was asked to read. I would always, go look beyond and see if there are better ways to understand the subject, or better ways to, you know present or teach the subject. The other issue with this uh, with a pure coaching model is that you are always comparing yourself to others, right? And that is very natural in an exam oriented approach. So it can distract you from focusing on developing a long term interest in the subject yourself, right? And then you start feeling stressed out. If you don't do as well as your peers, your self confidence goes down. You start feeling ashamed of, your of who you are. You start feeling jealous of others' success, and you start feeling that maybe I should abandon the race, right? I should abandon the subject because of not doing as well as others in this exam, which is meant to test your fluency on specific formulas, which actually have very little to do with with the core subject itself. And that is the irony, and that is, I would say, a sad state of affairs, that um, we are constantly measured, or students are constantly measured on exams which are not testing your, a true understanding of the subject. They are testing more how much you're fluent with the formulas and how quickly you can apply them. So, uh, okay, so let's go through these three questions and look at deeper answers to them. So, Kapil, I see there's a hand raised by someone. Do I just ignore it, or?
Yeah, for now we can ignore it. Let's build it up. But I think what is fascinating is Omkar. can it be said that each of these 158 people who are live right now
Mhm.
can find love in physics and can find or can expect physics to become very, very easy to them? I think ease is very, very important, right? If you're finding something difficult, for how long are you going to bear with it? So, can the students expect that physics will really become easy once they start understanding the way you are going to explain it to them?
Yeah, yeah, definitely. Actually, that's why I mentioned specifically that it has taken 2000 years for the best minds in the world to develop the physics that and the math actually, calculus, that you are expected to learn quickly, um, within a span of a few weeks or a few months, which is actually a very unfair expectation if you think about it from a high level, which is why everything ends up being memorization of formulas and applying them, right? It's like how you drive a car. You don't understand how the car actually is built or how it works. All you know is if I press this, it's going to accelerate. If I press this other thing, it's going to decelerate. So that becomes our approach to, learning any science subject, that we are just looking for those buttons to press so that we get the output that we want instead of understanding the internals. And understanding the internals is what is the heart of science education. So, and that is where the enjoyment comes from, because you're solving the biggest mysteries, right, Joe? I used to read a lot of these mystery books in my time. I don't know what kids in India read nowadays, but Enid Blyton's and, you know, a lot of these other, Sherlock Holmes and other series. Why are they fun to read? Because there is a mystery to solve, the, which is inviting, right? You are being invited to solve it with the author, or you're following the journey to solve it with all its twists and turns. And those twists and turns are what make things so enjoyable, so fascinating, right? Even when you watch a cricket match, when the scores are all uh, you know close to each other, and only the last few overs, or maybe the last over or two, will decide what happens. There's that excitement. Why? Because things could go either way. And that's what you realize when you learn science in the right way, that science is not something that you just discover. It is continuously being invented by people, by humans. And if you participate in that process yourself, you will you will go through those twists and turns yourself, and imbibe some of that excitement which the early scientists had as they went about developing the subject. They were not developing the subject for entrance exams, right? That's what we are using it today for. So if you put yourself in the shoes of those early scientists, then you will understand the subject in an exciting way, and anybody can do that. Not just that, if you look at, I spent a few years studying the works of Galileo, Copernicus, Newton, and others, and you will find them making mistakes. So you will find them making many mistakes that today you might not make, right? So when you see that, then you get the confidence that, okay, I'm not supposed to be, the expectation that I understand this subject in a few months is actually a very superhuman expectation. And so I shouldn't feel guilty for not having that conceptual understanding, but at the same time, I should have the confidence that if I learn things in the right way, if I spend a little time, I can understand it. Because um, I might not be better than others, but I'm also not worse than others. That's what confidence to me means. Confidence, self-confidence does not mean arrogance. It doesn't mean that you have to think you're better than others. What you have to feel internally is, look, I'm not worse than others, right? I have the same brain that any other average human being has. And so I just need to find a way to use it, so that which requires finding the right training, so that I can learn these subjects in a way that experts today have learned, right? Experts also started out as novices, right? So if they had given up at that time that I'm a novice, then they wouldn't have become experts. But you have to have some patience, right? Patience and persistence, which is easy to develop once you start enjoying the subject.
So, Omkar, this is fascinating. So, I think one thing which I want to do is, students, इफ यू आर कंफर्टेबल इन हिंदी, मैं थोड़ी देर के लिए हिंदी में बात कर लेता हूँ. आई रिपीट द सेम थिंग इन इंग्लिश. This is going to be a slow journey, right? This is not going to be like आपको कोचिंग में आज हम यूनिट्स एंड मेजरमेंट से चालू कर रहे हैं एंड बाय द एंड ऑफ द क्लास हम आपके एनसीईआरटी टेक्स्ट के 3 पेजेस कवर कर लेंगे. वी आर नॉट गोइंग टू स्टडी लाइक दैट एट ऑल. अभी we have already spent half an hour और हमने बस बात की है. By the way, I saw some very interesting authors' names. Someone said George Orwell, someone said H.G. Wells. Both are fascinating authors. So good to know that. But I want to tell you this thing, guys. यदि आपको जल्दी है, I know that you are pressed for time. ये जो क्लासेस होंगी, we'll try and do twice or thrice a week. You just sit back, थोड़े बहुत नोट्स ले सकते हो, ले लो. But this is slowly going to start unraveling how we arrived at that basic formula of F is equal to ma, for example, or your V is equal to U plus AT and all those things. If you are pressed for time, it is not compulsory that you attend these classes. Just give up. If you are okay slowly understanding physics with the assumption that over a period of time आपको उससे फायदा होगा, तभी आप ये क्लासेस अटेंड करिए. गुड न्यूज ये है दैट ओमकार इज गोइंग टू बी अ जर्नीमैन फॉर एटलीस्ट 2 चैप्टर्स, मोशन इन अ स्ट्रेट लाइन एंड मोशन इन अ प्लेन. और उसके साथ हम कैलकुलस ऑफ वेक्टर भी कर लेंगे. हमारा टारगेट इसे अगले 1.5 से 2 महीने में करने का है. बहुत आराम से चलेंगे, पर हम बहुत सारी चीजें उसके बैकग्राउंड में कवर करते जाएंगे. तो आपको इम्पेशंस है, तो इम्पेशंस को आपको यहाँ पे कम्युनिकेट करने की जरूरत नहीं है. यू जस्ट स्टॉप अटेंडिंग द क्लास. फॉर एग्जाम्पल, नहीं मिक्स नहीं कर सकते. टेक्नो प्लीज अंडरस्टैंड, डोंट टेल अस व्हाट वील डू बिकॉज स्टूडेंट्स आर देयर फ्रॉम साउथ एज वेल. So we are not going to mix it up. It is going to be pure English. Whoever feels uncomfortable with pure English, you can leave the class. But we will not change the medium of the class because you are telling us to do something, right? So what I was saying was, when we start moving on this journey, you might not be able to understand why am I spending time. If you're not able to understand why are you spending time, stop attending this class. Okay? But my assumption here is, and your assumption should be, there is we are going on a journey through which we will start understanding basic physics. That would make it simpler. We would develop interest in the subject, and that would ultimately lead to the short-term goal that I have to crack JEE or NEET. This person who's in front of you, as I said, he got a rank 17 in JEE. That is a very, very big rank, and he's exceptional in terms of studies. And he has arrived at this conclusion कि हमें यदि पढ़ना है तो हमें शांति से उसको एब्जॉर्ब करके चलना पड़ेगा. So is that okay? Every one of you understand what I'm trying to say? I will then hand it over to Omkar. And some people who are making random comments, I'll just have to remove you. I don't want to remove you guys, right? So let's be very, very peaceful here. If we are going to not not behave properly, that's not going to be cool. I'll just end up removing you because I have the power to do that. Okay, Omkar, over to you.
Okay. So let's go back to these 3 questions and let's try to develop a deeper sense of what the answers uh, could be. So let's start with the question of what is physics and how does it differ from other sciences. So how do we answer this question? Let's start by looking at the word. You might know that English is a language that has descended from earlier languages, Greek and Latin being two of the ancient languages that were a source of a lot of European languages. So the word physics actually comes from a Greek word called physis, which means nature. So if you talk to somebody in ancient Greece and you said I'm studying physis, they would they would they would understand it as you're studying nature or the natural world. Okay, but the study of the natural world the broad study of nature or the natural world for the ancient Greeks was a field that they called as. So if you combine physis with logos, so logos was again a word in ancient Greek which meant the rational study of. Let's say uh, you might have learned, like biology, for example, bios plus logos is the rational study or the systematic study of life. Anthropology, anthropos plus logos is the study, it's a scientific study or system, the rational study of humanity. Psychology, psyche plus logos is the scientific or the rational study of the mind. So, in a similar way, the broad study of the natural world, physis plus logos, was called physiology in today's terms. So, this might be confusing because physiology is something that you know is a subset of biology today, right? But this was the early term for the study of the natural world. It was not physics, it was not science. The word was physiology. So I hope you understand where the, what the meaning of physiology is. It refers to the study of the natural world. Now, what happened is over time, um, the meanings of these words changed. So in medieval times, the main purpose of studying nature in various parts of Europe shifted, because you might have studied in your history that there were a lot of infectious diseases that wiped out a large percentage of the European population in that period. So, grappling with infectious diseases became super important in a practical sense. So, there was a group of people who were studying nature, but with the specific purpose of developing medicines to heal the human body because of the rampant diseases in that time. And so those people who studied nature for this narrower purpose became known as physicians, right? If you look at the word physician, it's basically referring to somebody who studies physis, somebody who's studying nature, but for the narrower purpose of developing medicines for healing. Studied nature for the narrower purpose of developing of let me just say medical healing. And then the best of the physicians became known as doctors. In fact, the word doctor comes from uh, a Latin word which refers to teaching. So if you wanted to be a teacher in a medieval university, you had to be an expert in whatever subject you were teaching. So a doctor became a title for somebody who was an expert. So the most expert physicians became known as doctors. In fact, the experts in any field today are also called doctors. Like the word PhD, for example, means doctor of philosophy. And even though it says doctor of philosophy, because philosophy gave birth to all the different sciences, they didn't change the word philosophy, but they continue to call experts as doctors in any field. Anyway, so physicians, they studied, they were the physiologists. Okay, they were the people who were studying nature, but for medical healing. And their object of study, instead of being all of nature, narrowed down to the bodies of living things. And you can see how this led to the current definition of the word for physiology. But the bodies of living things were known as physique. Okay, so if you asked a physician, what do you study? They would say, I study the physique of living things. So the word physical in English also means pertaining to the body, pertaining to the bodies of living things, but in general, pertaining to the body. And so if you look at other English words, say metaphysical, metaphysical means pertaining to something beyond the body. Meta means beyond. So um, subjects that went beyond the body, for example, uh, religious topics, like pertaining to the human spirit or the human soul or the existence of God. Those were all topics that went beyond the body, and so they are still today considered to be part of metaphysics. All right, so if you see here, the physics comes from the word physis, but physis over time is contributing more and more to a study of nature in the narrower sense that um, you find in physiology today. Now, there were obviously many other people in Europe who were studying nature not for medical healing, but purely out of curiosity. And an example would be Isaac Newton, right? Say they might be interested in studying the night sky and the stars, planets, the sun and the moon in the night sky. Or they might be interested in studying how metals could potentially be transformed into other metals. Or they might be interested in studying vision, for example, or light. So these people who were studying nature not for medical healing, but out of curiosity, called themselves as natural philosophers. So if you look at the title of Newton's famous book, in which he um, gives Newtonian mechanics, the three laws of motion, the law of gravitation, as well as gives a method to understand, or a tool to understand his mechanics, namely calculus. That famous book is called Mathematical, when translated from Latin into English, is called Mathematical Principles of Natural Philosophy. So Newton did not consider himself a scientist. The word scientist did not exist that time. He did not consider himself a physicist because, physicists were really physicians, right? He called himself a natural philosopher. What did natural philosophy mean? Natural philosophy is what referred to in that time to a broad study of nature. uh, the word natural comes from there. And the word philosophy meant that you had to develop an understanding of nature and the rules governing nature by relying on reasoning, by relying on logic, by taking the responsibility to justify whatever you were believing. A non-philosophical approach would be one where you accept something purely based on authority. That's how most ancient people developed a worldview, and that's how most people today, those who don't study science or various um disciplines that emerged out of philosophy, they pretty much accept whatever they do based on authority. So if some book says, some revered religious text says something, I'll accept it. If some religious figure says something, I will accept it. If some teacher says something, I will accept it. Uh, we generally don't question, why those beliefs are true or whether they are true. We accept based on we accept something based on the authority of the person. A philosopher's approach is different. Philosopher takes personal responsibility to justify whatever they believe. This doesn't mean that they think everything that authorities are saying is wrong, but they will want to understand the reasons why one should, believe whatever they are saying. And if necessary, drop some of those beliefs. So this was Newton's approach as well. And natural philosophers in general studied nature by using logical reasoning, and mathematics was a part of that logical reasoning. Okay. Now, over time, as Newton developed mechanics and as mechanics was developed by later people, what happened is that natural philosophy started becoming more and more successful in explaining the world, right? And the questions that remained were narrower questions. So uh, uh, this investigation into nature, which relied a lot on observations, which relied a lot on experiments, which was becoming more and more successful, started making these natural philosophers feel that actually our field is different from what other philosophers are studying. Other philosophers are basically using reasoning, but that reasoning is not constrained by what you're finding in nature, right? We are constantly getting feedback from our experiments and our observations, which makes us correct our views and change them if required. Whereas other fields of philosophy don't seem to be constrained that much by observations and experiments. And so we should call ourselves something different, right? They wanted to distinguish themselves from other philosophers because of the success that they were having relative to other philosophers. And so this word natural philosophy changed into the word science, which referred again, it had the same meaning, right? Knowledge of the natural world. It still meant knowledge of the natural world in a broad sense, but using a combination of logical reasoning and observations and experiments. So a combination of observations or experiments. Some fields of science like astronomy are observational. You can't do experiments on stars. But mechanics would be more experimental. You can play around with blocks and so on and see how things move. So combination of observations, experiments, and logical reasoning with the emphasis on observations and experiments becoming more and more and more over time, right? So when we talk about science, it's not just the facts, the formulas, the knowledge that we have about how nature works. It is also the method that we use to arrive at that knowledge. That is also important. And this is called the scientific method. Now, there is no single scientific method. There are multiple variations of in the way you can combine observations and experiments with logical reasoning and mathematics and so on, but broadly speaking we call it the scientific method. All right, so the word scientist was invented in the 19th century as these natural philosophers became more and more successful and a new profession started. So earlier natural philosophers like Newton was not paid to do physics. It was just a hobby, right? Most of the scientists you learn about were not doing their science because they were being paid. They were doing it out of curiosity. It was their passion, it was their hobby. But at as science became more and more successful and it started getting applied for practical purposes, it started becoming a profession, and that's where the word scientist was invented. In fact, if you go to the early 1900s, you'll find that journals of science refused to use the word scientist because they found it like a very weird word, because natural philosopher was what they were earlier used to. And you find some of the famous scientists objecting to the use of the word scientist. Okay, so that's interesting. Um, anyway, but still, this still does not explain what the word physics means, right? We now understand what the word science means and how it came about, but what about the word physics? We thought we were trying to understand the word physics and we ended up understanding physiology. So physics today still refers to a broad study of nature and its laws, but we have the word science for it, right? So what's the difference between physics and science then? Of course, we know today that physics is a subset of science, but in what way? In what way is physics a subset of science? Or, yeah, let me write this is in what way is physics a subset of science, and how does it differ? Okay, now we understand that science refers to a broad study of the natural world using a combination of observations, experiments, and logical reasoning. By the way, this is just the subset notation from math. Okay, in what way is physics a subset of science? How does it differ from other sciences? So now we are getting to the heart of the question. And for that, uh, let me quiz you on some historical dates that you might have learned as part of your study of science. So there is something that happened 13.8 billion years ago. Okay, so this is a timeline of everything from 13.8 billion years ago to the present, and I'm just going to mark a few important uh, uh, time points in there. So what happened approximately 13.8 billion years ago? Anybody? The Big Bang. Yeah. So we had the Big Bang, which is the scientific, ex, you know, uh, uh, theory that explains how the universe came into being. Now, let's go 300,000 years after the Big Bang, where something new happened, something significant. What happened roughly 300,000 years after Big Bang? No, it was not life that started. Um, that was much later. It was not the formation of the Earth. Actually, atoms formed not immediately after the Big Bang, but 300,000 years after the Big Bang, and started combining into molecules. Okay. Um, between the Big Bang and the time when atoms started, we had subatomic particles, we had space and time. Okay, so we had space existing, time, we would have forces, we would have energy. We can say there was matter, not in the form of atoms, but subatomic particles, quarks, leptons, and so on. So 300,000 years later is where atoms started forming, combining with molecules. Okay, now let's move forward um, to, let's say, 4.5 billion years ago. BYA is just billion years ago. What happened roughly 4.5 to 4.6 billion years ago? Formation of the Earth, exactly. So the planet Earth formed, and you can say the solar system also. The entire solar system was kind of formed around that time, including planet Earth. And then roughly 3.8 billion years ago, something happened. What was that? Life, yeah. By the way, somebody asked, how do we know all this? Great question. Uh, that is what you should learn um, as part of studying physics and science. Uh, the Big Bang theory is actually a theory that was developed in the 20th century, right? So, if you want to understand how we know all these things, you would have to study multiple sciences: physics, chemistry, geology, biology. But my point is not, I'm just quizzing you on timelines to come up with an understanding of what physics is and how does it differ from other sciences. Okay, so that's why I'm giving this timeline. I don't want to, if you don't accept it, that's fine. Okay, but at least this will help you understand where physics stands in relation to other sciences. So life originated, okay, and started evolving. So that's, you need life to exist for evolution to kick in. So that happened around 3.8 billion years ago, according to the scientific timeline. And then roughly 200,000 years ago, something happened. Man's evolution. Yeah. So Homo sapiens, right? Uh, Homo sapiens evolved according to the scientific view of the past, and then we come to the present. Okay. So once you recognize what happened in each time point, you can actually understand why different sciences exist. So between 13.8 billion years ago and 300,000 years ago, you have space existing, time existing, matter, energy. Let me also add charges, okay, electric charge, etc. Very fundamental, basic constituents of the universe existing, but no molecules, and naturally no planets, no stars, no life. But these are the fundamental features that existed, and a study of these fundamental features is what physics is about. Now, 300,000 years later, once atoms form, then they start combining with each other according to rules or laws that are more complex, and they go beyond what physicists study. And so the study of how atoms and molecules, sorry, how atoms combine with one another to form molecules, this is what falls into the domain of chemistry. Now, 4.5 billion years ago, when the Earth is formed by many of these molecules coming together and organizing themselves into, planets and stars, specifically the planet Earth, uh, a study of these even more complex organizations of molecules into planets is what the field of earth science or earth sciences study. Now, when I say earth science, you're not probably used to it because it's not part of the science curriculum there, but here in the US, you have the option of studying earth science. So the earth sciences include fields like geology. Geology, again, the word geo comes from the word Gaia, referring to the earth. Uh, and logos, so study of earth, right? Study of the rocks, the continents, the mountains, um, the stuff that makes up planet Earth is geology. Although the Earth, as we know, is also surrounded by an atmosphere. So when we refer to the planet Earth, we are also talking about the atmosphere, which is kind of unique to the Earth. So atmospheric science is also part of uh, Earth sciences. We also call it as meteorology, atmospheric science. And then the Earth, apart from rocks and all, it also has oceans, right? So oceanography is also part of the earth sciences. So all of these fields exist because we have these more complex organizations of molecules into, a blanket of air, which is, in the form of a gas. You have the oceans in the form of liquid. You have the continents, which are solids, and they all have their own properties and their more complex behavior than something that is evident by just studying the properties of individual molecules, right? So you need new separate fields of science to study things at that higher level of organization. So that's the earth sciences. Then when um, life originates, you have an even more complex organization of molecules into life forms which are evolving. And this is what biology studies. Okay, the study of life forms, how they change. Um, and then one of the life forms, one species in particular, the species that we are part of, Homo sapiens, that species had a brain or evolved a brain which is the most complex object in the known universe. Okay, so I'll repeat that. The human brain is the most complex object that we know of in the entire universe. And it is so complex that we developed this ability to invent language, which is whose complexity is way more than the rudimentary languages used by other species of life. And that has allowed us to um, organize ourselves into societies or cultures, organized into cultures. And the study of humanity and the cultures, the societies that we organize ourselves into, that is part of the broad field of social science, the various social sciences. And these include, say, linguistics, right? The study of human language. Of course, culture has different parts, right? Um, um, if you want to study how humans govern themselves in these societies, that would be part of political science. If you want to understand, um, um, you know, what happened in these cultures in the past, you would rely on disciplines like archaeology, which studies uh, material remains from the past, history, which studies written artifacts from the sorry, writing from the past. Uh, you have economics, right, and various other social sciences, which are all studying different aspects of human culture. So now you see how the different sciences are organized. I'll write this down. Different sciences study the natural world at different levels of complexity. If you see over time, complexity is increasing in the universe. So I'll say different sciences study the natural world at different levels of complexity. So physics is the science that studies the most basic, the least complex features of the universe. The most basic features of the universe, which is why we call it the most fundamental science. Whereas if you look at biology, if you look at the social sciences, they are studying the most complex features of the universe, right? Um, so the quantities that physics studies, space, time, motion, forces, energy, charges, and so on, they are the most basic features which came into existence at the very beginning of the universe. And even though they continue to exist even in more and more complex objects that emerge later, right? So even if you're a biologist may be studying the behavior of elephants, but a physicist can also study an elephant, but focusing on the most basic features of the elephant. Features like what is its volume, what is its mass, right? How heavy is it? Um, and things like that. They won't focus on, how does the elephant function, or how do the organs inside the elephant function? What is its behavior? That's not the focus of physicists, but they can still study elephants um, by as long as they focus on these most essential features. And so physicists study the universe at all levels of scale. So this is one other difference. This is something unique about physics, that the basic quantities of physics are found at every level of scale, from a scale that is smaller than the size of an atom to a scale that's larger than, say, clusters of galaxies, because these essential features are found everywhere in the universe at all levels of scale. Whereas if you look at other sciences, chemists study molecules, and molecules, the sizes of molecules is restricted to a certain range in in scale. You can't have molecules that are smaller than atoms. And you can't have molecules that are as big as, say, the size of a galaxy, or even, let's say, the size of a human body. So, Earth scientists, right, they are studying things at planetary scale, not something very small, but also not something huge like, say, a galaxy. Biologists study life. Life forms, again, have a restricted range of scale. Social sciences, of course, study aspects of human culture, which also have, operate at a certain range of scale. But physics, um, these quantities are found at all levels of scale, from subatomic to galactic and beyond. Galactic and beyond. Whereas other sciences have a more restricted scale, molecular scale for chemistry, scale of the human body for biologists, planetary scale for earth scientists, and so on. So I hope this now answers, or gives you a good sense of why is it that, whatever topics are part of physics are part of physics and not some other science. Right? Going back to that question, what is physics? Well, yes, it is studying a study of the natural world, as some of you said, but other sciences are also studying the natural world. Where is the difference? The difference is, at what level of complexity are they studying the natural world? At what level of organization, what level of complex organization are they studying the natural world? Physicists study the natural world at the simplest level. Other sciences study the natural world at more complex levels. Um, okay, so now let's go to the next question. Second question, why should I study physics? Okay, deeper reasons for studying physics. Of course, it's important for your exams, that I understand. But let's try to seek a deeper um, reason, because only then will we be able to get that fuel to continue our study even when things don't look so good on the exam side, right? Uh, Even when we get a lower score in some practice exam, we don't get discouraged. So, why study physics? Well, why did these natural philosophers develop physics? Why did Newton develop physics? I would say satisfying human curiosity is an extremely important reason. Curiosity is something we are born with. If you look at infants, they're very curious. They're constantly exploring their environment. But at some level, at some age, what happens is this curiosity gets stifled by an education system that is artificial, where it's important to train, right, a large mass of kids, um, to in the same subjects, right? So human societies want adults who have a knowledge of, um, a basic knowledge of all the different areas of study. And so they developed this education system where kids of a certain age are all put together into a single classroom, taught things in the same way, almost like a factory system, right? In a factory, you want every single product that emerges out of a factory to look, to be reliable and look the same as any other product. And so when that was applied to the education system, everybody learns the same things, is taught in the same way. And the expectation is that when you come out of 12th grade or college, or at whatever level we see, you are all similar to each other. Okay. And that means it's important that you not deviate from the norm, right? If you start pursuing your curiosity in a classroom and start, like, asking the teacher, uh, what about this, what about that, the teacher may get annoyed, not because there's anything wrong with your curiosity, it's very natural, but because the system is such that if they start answering your personal doubts, then what about the other kids, right? They might be curious about other things. Everyone might be curious about different things at a certain point of time. And so if if curiosity was allowed to flourish in the classroom, it would lead to chaos. It would lead to indiscipline in the minds of the teacher. And that's so it's very unfortunate that human curiosity has to be quelled uh, to develop a system that works at mass scale. But that's unfortunately how the education system is. But as individuals, it is important for us all to pursue our curiosity outside the classroom if needed, if the classroom does not encourage us. Uh, Now, the amazing thing, if we go back to this timeline, we talked about how Homo sapiens evolved around 200,000 years ago, whatever. It is we humans who are trying to look back and understand this whole universe, where we came from. So it's human consciousness which is probably the most complex phenomenon in this universe. The most mysterious phenomenon in this universe is consciousness, right? The awareness that I exist. Um, um, it is a phenomenon that still has no convincing explanation. Right? Philosophers call it the hard problem of consciousness. We can't explain how consciousness or why consciousness exists or how it emerges out of simpler constituents of the universe, if that is the case. Or is consciousness a fundamental feature of the universe? So these are this is a question that is one of the hardest questions. It's still an unsolved problem. But one of the physicists whose name was John Wheeler, he came up with this diagram. It's like the same timeline that I showed in the, on this slide. He just organized it as a U to indicate a point that, so here's where the universe starts, okay, the Big Bang, and time flows like this. Now, as time passes, you see that this line becomes thicker. And this indicates that complexity in the universe is increasing. So the universe, when it originates, is very simple, becomes more and more complex. And at a certain point of time, we humans evolve, human consciousness comes into existence. And using that human consciousness, we are now looking back at the universe and trying to understand where we came from, where the universe came from. And this is something that is almost, uh, gives you a spiritual sensation. Uh, in fact, the famous physicist Carl Sagan, who was the host of a very popular series in the US called Cosmos, he used these famous words that we are a way for the cosmos. So the word cosmos again is a Greek word. It refers to the universe as an orderly entity. Okay. So if I call the universe as chaos, that means there's no order. So a cosmos is the universe looked upon as an orderly entity. There are laws, right? It's not a chaotic. It's not like there's chaos everywhere and you can't make any sense of it. It's an ordered universe, and we are the way for the universe to know itself. Is how he, uh, you know, thought of things. And what have we come to know using our human consciousness? Of course, we can say we've come to know all of this, but um, I will give you another quote by Carl Sagan, very famous quote. It's called the pale blue dot quote. Actually, a spacecraft called the Voyager that was sent to explore outer space. So in the 90s, when it entered the outer regions of the solar system, it took a picture of the Earth. And I don't know if you can see that here, but it's like a very small pale blue dot that you can see here in this vast emptiness of space. And looking at that picture, Carl Sagan uh, wrote the following. Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was lived out their lives on that pale blue dot. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father hopeful child, inventor, explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species. In other words, anything that matters to us in human culture has happened on that mote of dust suspended in a sunbeam. The earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors that you study in history, so that in glory and triumph they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our imagined self importance, the delusion that we have some privileged position in the universe are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit, yes. Settle, not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy, or we can say science in general, is a humbling and character building experience. There is perhaps no better demonstration of the folly of human conceit than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known. So it's a paradoxical situation. On one hand, we are saying that the human brain is the most complex object in the known universe. And using the human brain, though, uh, using by inventing the different sciences and pursuing our curiosity, we have come up with a view of the universe, a view of space and time in which we are actually extremely insignificant. All right, but if this doesn't, like when I read this quote the first time, it actually I saw this him saying this in that documentary series called The Cosmos. It sort of raised my, I started feeling like my hair is standing on end, almost like a spiritual experience when you reflect on this in silence at, what our position is in the grand scheme of things. All right, so why study physics? To satisfy this natural human curiosity. If we are the way for the universe to know itself, that means pursuing that curiosity to understand the universe is the best possible thing we can do with our lives, right? What else does, in the grand scheme of things, what else is more important in life? Everything else that you pursue is going to end anyway. So everything is temporary, but knowledge of, the universe will go on, right? Reality will continue. And so if we are in touch with that absolute reality, then we are in touch with something that will persist beyond our own existence. So this is how a true scientist looks at what he's doing. It's basically the most uh, important thing that one can do with the limited time that we have in our lives. And so part of this also becomes teaching others, right? Helping others understand the universe is also part of the same thing. And that's why, like, why am I teaching here, right? I don't need your money, right? I'm not charging anything, or I don't even do this as for my profession. It's because I feel it's important for me to spend my own time on these matters, uh, because this puts me in touch with the core of who I am. Okay, and so if you develop that curiosity yourself, it will continue beyond your exams. So now you can see that exams might be an individual event that's important practically in your life, but in the grand scheme of things, it has no ultimate value, right? Unless you use it in the right way to pursue a career and a life in which you are propagating forward. Um this same, you can say, mission of humanity to understand themselves and the universe. So we uh, we will we will try to learn physics in a way that is aligned with this goal. But remember, I also mentioned that science is not just about the facts that we know or the knowledge that we have invented, but it's also about how we know what we know about the universe. Like, it's important to ask, how is it that we came up with this kind of picture? How do we know anything for that matter? So that is also something we will focus a lot on, right? So the combination of observations, experiments, and logical reasoning, which led some people to propose that this is the way the universe works. These are the laws. This is what happened in the past. Justifying whatever we believe. Without justification, we cannot claim to have knowledge. All we have is a set of beliefs, right? So when we study science, it's important to also keep asking, how do we know what we know? So I would say satisfying human curiosity, justifying our beliefs. Well, this isn't the reason why we study physics, but I would say learning how to justify your beliefs is actually a life skill, an important life skill. Learning how to justify your beliefs based on evidence is not just, the method of science. It's actually the method of it's the method of philosophy. And because philosophy gave birth to all the different fields of knowledge, it's the method of all fields of human knowledge, right? Even as medical doctors, future medical doctors, where you are expected to heal patients, you want to follow evidence-based medicine, right? Otherwise, you would be playing with the lives of your patients. So it's true for all science. Now, the thing is, physics, um, in some ways, takes this to the next level. And what do I mean by that? Because physics is studying the most basic aspects of the universe, there was a language that physicists developed to capture those most basic aspects of the universe. And that language is the language of mathematics, which is unreasonably effective in describing those basic aspects of the universe, right? So, mathematics is actually harder to use for capturing more and more complex um, um, aspects of the universe. For example, when you come to biology or the social sciences, you already know, right? Biologists, social scientists, they don't use math in the way that physicists use math. Math is still helpful even in every field, but it's used for specific purposes there. Whereas in physics, math is the language in which you study physics. If you don't use math, it's very hard to do physics. So these other sciences are increasingly more qualitative, right? You don't have an equation that describes how an elephant behaves or how a human behaves, right? So these sciences are more qualitative. Physics is more quantitative. It's more mathematical. And it is this which allows physics to make exact predictions, because math can be used to make very precise, exact predictions which emerge from the language of math itself. So, um, learning how to justify your beliefs based on evidence and a lot of math, and a lot of math is a life skill, because once you learn how to do that, you will never be afraid of any field. So I'll show you another quote by Galileo Galilei, who, if we continue, this series of classes, I will tell you a lot about him later. But one of the things he wrote is that um, philosophy, or you can say natural philosophy here, is written in this grand book, the universe, which stands continually open to our gaze. But you cannot understand the universe unless you understand the language in which it is, or the laws of the universe are written, right? So, what is that language? In Galileo's time, it was mathematics, but math in his time was mostly geometry. Okay, algebra was, at least in the way we study it today, was being developed or had just being developed. It didn't have the respectability yet that it has today. And so, using geometry to calculate and derive and compute a lot of things about the universe was something that people did in his time. And so the characters of that language are therefore triangles, circles, and other geometric figures, without which it is humanly impossible to understand a single word of the universe. Without math, one wanders about in a dark labyrinth. These are Galileo's words. And so the use of mathematics and logic, in fact, why is mathematics valid? Why is it so unreasonably effective in making predictions that invariably, come out true? You develop math in the context of astronomy, and you find that the same math uh, makes accurate predictions in other areas of human knowledge. Why is math so unreasonably effective? Well, one way to look at it is math itself is grounded in very rigorous logic, and once you couple math with observations and experiments, the constraints that come from the real world, you get a science like physics, which is a very hard science. By hard, I don't mean difficult. Of course, it can be difficult, but when I say hard science, I mean a very respected, a very rigorous science. If you uh, if you look at social science is many times not considered a science. Right? Why is it so controversial to use the word social science or social sciences? Because many people feel that they don't deserve the label science because they don't have that predictive power that, say, a hard science like physics has. So I'm not saying that it's fair. Obviously, there's a lot of value to every field of human knowledge. But fair or unfair, physics has the most respectability among all the sciences, probably because those who master it are not afraid of taking on a study of any other field because of the mathematical maturity that they develop in modeling the real world. And there is this again, a famous quote. We don't actually know if Rutherford actually said this, but it is claimed that this was published in a journal from the American Association for the Advancement of Science in 1945. All studies become scientific to the degree that they aspire to reach the condition of physics, and to the extent that they seek to imitate closely the complex interweaving of observation, experiment, and mathematical elaboration, logical reasoning, which is to be found there. Those who favor this definition may take as their slogan the epigram attributed to the late Sir Ernest Rutherford, that science consists of physics and stamp collecting. So he was kind of um, apparently dismissing the other sciences as just stamp collecting. What do you mean by stamp collecting? Basically, collecting a bunch of disjoint facts about uh, the universe. Obviously, that's not true. We know, for example, in biology, evolutionary theory is like a unifying theory which allows you to integrate a lot of different, you know, all the different areas of biology. Um, so, uh, but this was a view that was prevalent then, and you can say that many physicists today also feel like that about their field, that they are sort of the cream of all sciences for this reason. All right, so Why do we study physics? Going back, I hope I've answered that question. Satisfying human curiosity and learning how to justify your beliefs based on evidence. And so when you look at learning math, whenever you feel burdened by math, remember that math is ultimately a way to use logical reasoning to justify, your beliefs based on evidence. That's the purpose of math in physics. It is not to drown you in a or to crush you uh, for the sake of crushing you. That is the purpose. And if we learn physics in the right way, you will see this purpose very clearly coming out. In fact, this can be the best motivator for you to learn math, to want to learn math. That I want to understand um, um, physics or reality better in a more effective way. Now, going to the last question, I hope it's okay, Kapil, if I take like few more minutes.
That is okay. I just want to, Omkar, mention one thing. A lot of students who have joined this uh, will probably not have opportunity to study a lot of math because they have chosen physics, chemistry, and biology.
Right.
So, I just want to make sure that students understand that is all right.
Mhm.
Uh, and we can still learn physics, and we will get to our immediate requirement. But hopefully, as we go along, as I'm captivated by what I've heard from Omkar in last 10-15 minutes, starting from what Carl Sagan said, और मुझे ऐसा लगता है कि my son is sitting right next to me, so I'm fascinated by the fact that we are trying to get to where and why we we should study physics. So it's very good. So let's continue. Let's finish up this question and then we'll set up the next class.
Okay, yeah. So the third question, right? Um, yeah, I will again say that. So I understand that you may not have the opportunity to learn math, but like I'm not talking about what you need for the exam, right? For whatever little math you need for the exam, for now, that's fine. This is something you can continue in a all across your life, right? Even when you become doctors, when you're reading um, medical journals, there will be some statistics, there will be arguments for why certain treatments are more effective than others. And if you understand the language of math, you can even understand how is it that medical researchers are able to develop treatments and argue that this treatment is effective, um, whereas that treatment has not shown to be effective, right? So it's a general skill and you can pursue it all over your life. You don't have to like learn everything right now. For now, you can be more practical and focus on what you need over the next year or two. So, how to study physics, right? The last question. So, um, I would say part A is let your curiosity drive you. Let your curiosity drive and guide you to ask and pursue uh, grand questions, okay, or big questions, big basic questions, which can be the starting point. All human cultures have asked basic questions. What is the nature of the self? Uh, Questions about the existence of God, questions about the origin of everything, questions about the nature of happiness, meaning of life, meaning of death, existence of free will, meaning of good and evil, and so on. So, a few of these basic big questions are relevant for physics, and we will take those one or two such questions as our starting point to embark on this journey. Okay, but curiosity is a good thing. That's my point. Let your curiosity drive you and you will start enjoying. Second, like I said, we will work on justifying whatever whatever physics we develop or accept. So we want to use our experience, but of course our experience is very limited. But we still want to understand others' experience. What experiments did they do? What did they find? How does their experience of the world, particularly, gathering observational data or experimental data, how is that relevant to answering, the big questions that we are asking, right? Ultimately, nobody does aimless experiments, right? Even any experiment you do has to be planned because you think that something will come out of it which will help you clarify the answer to some question you have. Maybe you're not sure, is the answer this or is the answer that? You have different hypotheses about what could be the answer. And so you plan an experiment in a way, in an intelligent way, so that the outcome of the experiment will favor one answer over another, right? So that is the purpose of uh, designing experiments. So mixing in logic, okay, justification means mixing in observations, experiments with logic and math to figure out which answers make the most sense in terms of being justified. And if there are multiple answers, see which answer is the best answer. And maybe the best answer is what you end up accepting as your belief. So we will go with whatever the best possible answer at each step is, but we will keep our mind open to iterate because we might encounter new observations after some time, maybe after one or two chapters, where counter arguments emerge. And that might require us to refine or change whatever we have been accepting till that point. And so we might ask, well, can our current worldview handle these new observations, or do we have to change something about what we believe? And this is how science itself has evolved. And this is the way we want to reinvent the physics or the mechanics of class 11. Right? This is what will preserve your sense of joy, wonder, curiosity, playfulness, exploration with a much deeper conceptual understanding. So if you're looking just for fluency in the application of formulas, if you're short of time, focus on whatever your coaching institute or what your tutors are telling you to do. These classes might not be right for you, but if you are open to, you know, uh, following this path, you have the time, then this is the way you should do it. And I would say the last um, feature of what we will do is whenever we are justifying our beliefs, we don't want to wave our hands. We want to be clear about the meanings of words you use or you encounter. Okay. After all, the language of physics is mathematics. So the meaning of many of the words you learn might be expressed as an equation. Okay. So, um, so like I said, this is the best reason to learn whatever little math you need to understand physics at your age. And it's not some, you should not look at math as something different. To the extent that a bunch of math topics are separate from physics, you can, ignore them. You just want to
Omkar,
do.
I have to interject. You said something very interesting. If you can give a quick illustration of what you mean, you said physics is expressed through some mathematical equation. Can you give a specific example of what you mean?
So, for example, uh, the English vocabulary that we use in mechanics, like work, force, energy, right? These words are found in English language, and they have a connotation, right? A popular connotation. Like if I am, if I pick a suitcase or if I hold an heavy object in front of me, I'm doing work, right? But that might not be the meaning of work in physics, right? Just holding an object still in physics may not amount to doing any work because the way the word work is redefined in physics could be different from how we understand it in our English vocabulary. So this is actually a very common reason why some students find physics hard to understand because the words used in physics seem to be the same words that we have in our English language, at least in mechanics. So we tend to transfer that common understanding of that of the meaning of that word when looking at physics problems as well. Whereas we forget that, well, what physicists mean by work could be very different from what we mean by work, although there is some overlap. There is might be some overlap, which is why that particular word was chosen. But we have to, just like theory in science, right? When we say scientific theory, we mean something that is very well established and reasoned. But if you look at what the word theory means in common parlance, theory just means, oh, that's just a theory, right? That's just a speculative guess that you're coming up with. It's not reality. So you can see how there are two very different meanings of the word theory. And in a similar way, in physics also, I would say the English vocabulary, let me just write that down. The English vocabulary has different meanings. Like work might be defined as the dot product of force and displacement in mechanics, which can be very confusing. Firstly, why do we need to define this quantity called work? Why do we need to define this as a dot product? Why should this dot product operation even exist? Why come up with that? Why not define it in some other way? These are natural questions, uh, which do need to be answered as we learn mechanics. But the point here is, keep in mind that English vocabulary has different meanings for familiar words that we use in physics, like work, force, energy, etc. So, um, so these are the three ways in which we will learn physics. Pursue big basic questions that pique our curiosity, justify your beliefs, um, and be clear about the meanings of the words you use in whatever arguments or justifications you come up with. So, if we want to follow this approach, you can actually drop whatever you think you know for the purpose of these classes, except maybe the math that you know till class 10, basic algebra, basic geometry, and we can build up our knowledge of physics from scratch, right? So the big question that we are going to start our study with is, what is our place in the overall map of the universe, right? Can we come up with a 3D model of the universe which explains our place in it? And if we were to start from a blank slate from scratch, pretending that all human knowledge is wiped out, right? How would we build back the edifice of, um, say, Newtonian mechanics or the Newtonian view of the universe from scratch? That is going to be the way we approach mechanics.
Wow, very good. So, Omkar, we stop here, or you want to continue?
So it's up to you. I think this could be a logical point for stopping, but if I continue, um, I would need at least half an hour more, right? No, I can't like stop in 5 or 10 minutes
Got it.
because
I want to ask this, guys. Should we go half an hour and then stop? And what we will do is we will ask Omkar to also explain, or rather, give us a peek view of what it would be like in next 3 to 4 classes.
Mhm.
What I'm recommending is we do half an hour more, and at the end of it, guys, whoever is saying end, please, we will make the recordings available. You can go, that is perfectly okay. Uh, but I think it's a good flow, and let's do half an hour more, and then we stop. Omkar, please go ahead.
Sure. Yeah, that will let me give an example of, some rudimentary application of what I have written here, uh, which we will then continue in future classes. So, like I said, the big question that we want to use as our starting point, which is completely missing, like I said, in mechanics. This is actually the big question that led to the development of mechanics, which is, what is our place what is our place in the overall map. Uh, Map is usually flat, so let me call it a 3D model. Can we come up with a 3D model of the universe relying only on the methods that I mentioned, right? Observations, experiments, and reasoning. And when I say observations, not observations from today, okay? Not satellite pictures or anything like that. Imagine uh, all human knowledge is wiped out, and you wake up, maybe not all human knowledge, maybe you can still still need to survive as a human, so maybe you're living as a farmer somewhere, right? You know how to grow your crops, you know how to you might have domesticated animals. So those basic uh, tools, basic technologies available to you, but you don't have any knowledge of what the world is like, and you're a child growing up, right? As a child, you obviously don't, you start from blank slate. So when you look around you, yeah, you can't observe very far out in the universe, right? So and it's okay, right? We can be allowed to imagine, to come up with a model that goes beyond what we can observe, as long as we are open-minded to refine it when we are given new data in the future, which we will be given in the way we proceed. So firstly, um, if you think about it, you're living, let's say, somewhere in the Indo-Gangetic Plain, right? If you're in India, you look around you, the piece of land that you live on um, obviously has limits, right? But um, we couldn't reach that limit in ancient times, right? We couldn't travel very far out of, say, India. Maybe the Himalayas block our path, or um, the oceans block our passage, or even if you want to continue in a straight line, you may not be able to continue in a straight line. There will be various geographical barriers, but you could um, talk to other travelers, their experience of traveling to far out places, and gather um data from them, and you could come up with a map of this form. Now, this map was actually something that the ancient Greeks came up with. So imagine that you are not, of course, this is in our imagination now, we are in Greece, not in India. But the Greeks knew that if you travel west, you have all these regions. You can see here a rudimentary map of Italy here, and so on. And if you go further and further to the north, um, you might hit the ocean there, and so on. Um, and of course, what you find missing here is there's no Antarctica, there's no North and South America, because that was not possible for them to uh, reach using the technology available to them at that time. So there seemed to be ocean on all sides, and so what they had in their rudimentary map was basically a flat Earth surrounded by an ocean, or you can think of this as a massive river that extends on all sides of the landmass that we know. So they thought that there is this river that might reach the ocean here, the Nile River here might reach the ocean there. So they were sort of obviously wrong about the extent of these rivers, but overall, this is what at least some of them thought. Okay. Now, why does it make sense to think of, or why would you or somebody in ancient Greece, or I, for example, would find this a reasonable map, at least of the Earth? We haven't come to the universe completely yet, but just the Earth, the geography of the Earth. If you plant yourself in the middle of let's say the plains, or some grassland, and you look all around you, it makes sense to think of the Earth. You would see the surface of the Earth extending out in all directions with no limit. So it feels like the Earth is flat. Even if you're sailing in the middle of the ocean and you look all around you, you see the surface of the water extending in a flat way. out in all directions. Okay, so it makes sense to think of the land we think of as overall flat. Now, of course, you might encounter mountains. You might see the Himalayas, and even in Greece, it's a pretty mountainous country. But so how would you make sense of these mountains? Well, one way you could think of them is analogous to creases on a towel, right? You take a towel, put it on a table, and there might be these temporary creases here and there, which fold up the surface, so it's not flat. But overall, at a high level, when you look at the towel from the top, you would claim that it is flat. Just like, if I ask you, is this table flat or not? As a human, you'll say it's flat. But if you look at the surface of the table with a microscope, you will see lots of mountains and valleys, right? So in the grand scheme of things, overall, if we were to use, if somebody asked you what is the overall shape of the earth, you would say it's reasonable to say that it's flat. Um, when you look at the sun setting in the ocean, for example, and you look at, say, the horizon line as it cuts across uh, the sun, that line is flat, right? If the earth was, let's say, spherical, if it was curved, then you should see the horizon line as curved and not flat, right? That's how people argued at that time. So it made sense to think of the earth as flat. Okay, so I hope everyone agrees that this would be a reasonable model. I mean, in India, we had a different map. If you look at the geography that's found in the Puranas and all, but it's overall similar. A landmass. Uh, uh, we might be the area we are familiar with might be a very small piece of that landmass, but overall there's some kind of landmass surrounded by an ocean on all sides. So that's about the overall geography of the Earth. Now, in those days, people were also deeply familiar with the night sky. There was no light pollution, there was no electricity to block our view of the night sky, there was no pollution, air pollution and all to block our view of the night sky. So, free of light pollution, when you look at the night sky, you see countless stars. Of course, you see the sun during the day, you see the moon, uh, but you also see countless stars. And let's focus on the stars here. If you follow the how the stars move across the night, you would find that every single star rotates in a circle. So this is a picture taken from one of the hills close to where I live, where uh, the camera is opened. Light is coming in across maybe a few hours, and the path followed by each star is tracked, and you can see that they are all circular arcs, right? So if this camera was kept open for a full day, of course, during the day the sunlight would block off all this light from the stars. But you can imagine that all the stars are going in circles. The circle has a center. Okay, we can call that the pole, right? And the stars are moving synchronously. They're all moving with the same, we can say, angular velocity. Okay, if you're not familiar with the word angular velocity, but they're sort of uh, um, traversing the same angle in the same unit of time, right? So it's not like some stars are rotating faster than others in terms of the angle that they turn by in across whatever time you are measuring. So they're all moving together synchronously, keeping the same distance from each other. Okay, because stars maintain the same distance from each other. When people saw these random patterns in the sky and wanted to make sense of those patterns, they came up with constellations. Right? The only way to make sense of thousands of stars that you see in the night sky is to maybe focus on, let's say, the brighter ones and focus on the shape that is formed. You might have, as kids, solved uh, those puzzles, right, where there are a bunch of dots and then you connect them together to make a particular shape. right? You join 1 to 2, then 2 to 3, 3 to 4, and so on. And at the end, you see some shape emerging. So in a similar way, uh, there are a bunch of these dots, and you might connect some of them to form shapes called constellations, which remain stable because the stars maintain the same distance from each other. You would see the constellation also moving in the night sky along a circular arc, right? So how would you explain this kind of motion? So here's just a, as a farmer, you might come up with a constellation like a plow, for example, or a dipper, which is like a spoon, right? If that's the technology that's available to you in your house, you might see these kinds of simple shapes, and you would see this dipper constellation rotating in a circle. So the stars making up the constellation don't change their separation. So how would you explain this? Why do stars move um, in this way, keeping the same distance from each other, allowing you to define stable constellations? And these constellations were often, divine personalities or heroes from the stories in your culture. And so when you looked at the night sky, you would remember those stories, right? Because you would be seeing those divine personalities. You might also think of the sun, the moon, the stars, some of these constellations as gods or heroes in your culture. It's very natural. Now, to explain the synchronous motion of these stars, one hypothesis that um, people came up with. Oh, yeah, by the way, somebody just pointed out. Yeah, the star at the center is actually not exactly at the center here. Today we call this the pole star or Polaris, but that also moves in a small circle. Yeah. So uh, yeah, going back to my train of thought, what sort of 3D model of the universe would capture this? Um, well, here's what some of the Greeks felt was natural. The fact that the stars are moving synchronously means that there is something that is keeping them together. And one simple model that we can imagine is that they are all embedded in the surface of a transparent sphere, right? So think of all of them lying on a sphere, and it's that single sphere that's rotating around, rather than all of these stars independently somehow rotating in a way that miraculously maintains the same separation, right? There is some connection that is keeping them moving in the same way with the same angular speed. And so put them all in the surface of a sphere and make that single sphere rotate. And that would explain the synchronous motion of the stars, right? So the so if you think of a sphere, the top pole of that sphere, so if you thought of a 3D sphere, I actually have a model of this sphere, but I don't have it right now to show you. Maybe I'll show you next time. So imagine a 3D sphere like this, right? And uh, you have a pole, you have an axis around which this sphere rotates. So you are on a flat Earth. So I'll just draw a flat Earth like this. So you are here, and you look at the night sky, and you see that all the stars in the night sky, which are embedded on this sphere, they rotate in circles, circular paths. Some of those stars, they seem to lie completely above the horizon as they rotate, but other stars, they would have to go below the horizon and then rise up again. Okay, and um, so when they set below the horizon, where exactly are they setting? Now let's go back to that map of the world. Okay, so this ocean, imagine this ocean stretching all the way out to that sphere, right? I mean, there's no reason why it shouldn't. So extend all this out to the sphere, and so when the stars that are setting, they're actually plunging into the ocean. They would have to take a bath in the ocean, which would make sense if they are divine personalities. Think of them as taking a bath in the sacred ocean and then rising out from it again. And this was like one particular view. So if you imagined a stick forming the axis of that sphere, uh, we can call this stick as the pole. A star here would be called as the pole star because it seems to lie entirely on that pole. And of course, there will be another pole. We can call that the south celestial pole. So this sphere was known as the celestial sphere, or you can say the starry sphere. And this particular point around which all the stars seem to rotate for us was called the north celestial pole. North celestial pole. Okay, if the Earth is flat, there is no notion of a north pole on the Earth or a south pole on the Earth. But you can talk about a north celestial pole and maybe a south celestial pole also, although you can't see it because it seems to lie under the Earth in some sense. So, and at the north celestial pole, you have the pole star. Um, and the starry sphere, you would think of the starry sphere as forming the outer limit of the universe, because beyond the stars, what else is there? There's nothing. There's just a dark expanse. And why would there be so much empty space with no purpose or meaning, right? So there would typically be some kind of creation story in your culture which would explain how these stars, or rather these divine personalities in the celestial region. So celestial means divine, right? This is the region inhabited by the supernatural entities, the gods or God, or angels, or whatever else you have in your culture. Uh, and those personalities are going round and round, right? That's their abode, or maybe that's their chariot. And so so that's the celestial region, right? The night sky is the celestial realm, and where you are is the terrestrial realm. Terra is just a way, the Latin word for earth. And so you live on the terrestrial realm, and then in the night sky you have the celestial realm. In fact, you could define directions. You could come up with directions when traveling by looking at the pole star, right? The thing is that the pole star does not lie vertically over your head. If you're living in, say, India or even in Greece, it would lie at some angle in front of you. So the highest point, so if you look at the starry sphere vertically above you, that point is called the zenith, and that's not what we are calling as the north celestial pole. Okay, that's why I've depicted the axis in a tilted way. This point, uh, well, actually not that. Vertically above you would be this point, so that would be the zenith, and that's not very significant. Okay, what's significant is the north celestial pole, which lies at an angle. And if you were to drop a vertical line from there, that vertical line would hit the plane of the earth at a particular point. And that particular point is what you call as true north, or that particular direction is what you would call as true north. So whenever you are lost in the wilderness at night, you could navigate. You don't need a magnetic compass. You could navigate by looking at where the pole star is. Right now there is a star very close to the north celestial pole called the pole star. But in even if it wasn't there, you could look at the constellations which are close to the north celestial pole, see where they are, and use some rules of thumb to figure out where the pole is. Like this famous Big Dipper constellation was such that if you connect the two stars at the head of this dipper. Dipper just means spoon. If you connect the two stars at the head of the spoon, it actually goes and so just follow that, and you stop at the very first star you see. That's the pole star, and then you drop a vertical line from there that would give you the direction of the true north. then you turn completely around, 180 degrees around, you would be facing true south. And if you were to stretch out your hands like this in the east-west direction, that would give you the east-west direction. So that's how you figure out or define the directions. And because in the northern regions, the Greeks knew that those regions were much colder, there were bears living there. The Greek word for a bear is Arctos. So they called the northern regions as the Arctic region. And so the southern region, which was opposite to the northern regions, the southern regions were known as the anti-Arctic. Today we call it as Antarctic regions. But uh, you could use the stars in this practical way to guide yourself as you're sailing in the ocean, for example, where you have no natural landmarks. How would you follow your the right path? Well, by looking at the stars, the constellations, and figuring out the directions like this. Okay, so um, the sun and the moon you might think are closer to you than the stars because they are brighter, they're bigger, and so they would have their own independent uh, uh, path over uh, the celestial region. But the stars are all moving together. They are faint, they're small, they form the outer regions of the universe. Does that make sense? Does this kind of model make sense where you have a flat Earth? You have a flat Earth. The view from the top is something like this, and um, this flat Earth is actually the center of a spherical universe. Why a spherical universe? Because the stars are embedded in the surface of a celestial sphere, which is rotating, forming the outer limits of the universe. And so this is a very rudimentary flat Earth cosmology. Cosmology, again, the study of the cosmos or the ordered universe as a whole, which I think would be a very natural model to start out with if you had, if you were to build a model from scratch. So, any objections to this?
Omkar,
Now,
actually, I'm thinking,
yeah.
how am I supposed to object?
Is there anything that you, as a farmer living in India, for example, would see that would contradict this model? Is there any common observation that you can think of? Forget about satellite images and all that. Forget about all that we know from modern science and modern technology. As a farmer living in, the plains of India, would is there anything you can think of uh, which would contradict this model?
And the model being a flat Earth model.
Yeah, a flat Earth, uh, uh, which lies at the center of a spherical universe.
Hmm. One thing, somehow, as I keep moving forward, more and more of the view gets revealed.
Yeah.
So,
But the problem is that ultimately you hit the ocean. I mean, if you were in Greece, you hit the ocean, or you ask travelers, they will say, "Yeah, I hit the ocean. I traveled north." Um, and so let's also think in terms of a rudimentary physics. Okay, think about the fact that whenever you drop a solid or a liquid object, it always falls down, right? In
correct.
your experience, common experience, fire maybe rises up. Air, you can say it rises up. If you think of bubbles in water, they rise up. So air maybe tends to rise up, um, but normal air won't rise up because you have this. This is like a solid sphere, right? It might be transparent, but it's solid. So maybe there's no space for air to move further up. But fire would rise up in air whenever you light a fire. And so it makes sense for space to have direction, an absolute direction. We call this direction up and we call this direction as down. Solids and liquids tend to fall down. Fire tends to rise up. Maybe air also tends to rise up. Um, and that's the physics. And so if the earth was of any other shape, actually, here's the natural question that you would ask. Why isn't the flat Earth itself falling down? Right? What's keeping this Earth stable? Now, there are different answers to these questions. One answer is that, well, let's fill the entire bottom half of the universe with water. Okay, if you finally you have oceans, right, when you go in any direction. And if you think of the entire landmass of the Earth as floating on top of a subterranean ocean, like wood floating on water, then you can explain why the Earth is not falling down, right? So that's one mechanism. But so if in case you objected that, well, if even if I go to the ocean, I see rocks under the ocean, and those rocks, whenever if I were to pluck out a rock and put it in water, it always sinks down. So why aren't the rocks on the Earth sinking down? It don't seem to be made of wood. Um, some philosophers might object that, well, overall, if you keep going further and further down, it will be a kind of solid that floats on water. And others might say, well, sure, maybe there is some part of the Earth that is solid enough to reach all the way down so that it doesn't fall, uh, right? Uh, but this was actually an important question for philosophers in that time. Why is the Earth, uh, what makes the Earth stable? In fact, one philosopher proposed that the Earth actually continues down forever. It's like an infinite regress problem. When there is nothing under the Earth because the Earth just continues forever, and so there is no end to it. Of course, that philosopher is not consistent with this spherical universe model because the universe has a finite size. You can't just continue forever. But there were philosophers speculating in all kinds of directions, right? Freely pursuing their curiosity, coming up with all kinds of models. But ultimately, what we want here is imagination में तो कुछ भी हो सकता है. There are zillions of possibilities. Which ones make the most sense? Which are the simplest models that don't contradict our observations? And so something like this would be reasonable. This may not be the only model, but broadly speaking, a flat Earth in a spherical universe seems to be a reasonable point to start out with. Nobody would call you a fool or a duffer if you were to believe in this, because when you don't have all the cumulative knowledge that has been built over last 2000 years, this is quite logical, right, given the information and the data that is accessible to you. In fact, um, in the Near East, um, in the creation story in Mesopotamia, and even in uh, 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 I think in this Genesis story in the Bible, uh, there was water not just below the earth, there was also so at the beginning of creation there was water all around, because think of the fact that the sky appears blue in the daytime. Why is the sky blue? We see the water as blue, so it's logical to think that there is water in the sky as well. So why is it that how can water exist there? Well, imagine at the beginning of the universe, this entire universe is filled with water. That's the state of chaos. And then there is a bubble that is formed, a hemispherical bubble. So imagine a universe where this whole thing is blue because it's filled with water. And then a hemispherical bubble is formed like this with air inside. And you'll find this in the creation stories from the Near East, where a bubble is formed, and then this part, of course, becomes land. Various animals, humans, and all are created, and then there is the dome of the sky, right? This is a hemispherical dome of the sky, and it's solid, and because there's water above it, you see the sky is blue in the daytime. But occasionally, if you behave badly, right, as a culture, then the gods can punish you by making a hole in the dome, right? Making a hole in the dome, which can cause the waters above the sky to come in and cause a flood, wiping out all humanity. right? So there are these popular flood accounts in multiple cultures which have that kind of an event. So um, and then things get restored, things get restored, and in some stories, um, God or the gods, they they form some kind of contract with humanity. So think of a rainbow, the shape of a rainbow as it goes across the sky. The rainbow is something that goes along the dome of the sky, and it's a contract between you and the divine being or divine beings that if you behave properly, the flood is not going to happen again. They won't poke holes in the dome of the sky to cause a flood again. Um, Things will remain um, good for humanity, and the rainbow is, sort of a contract with God that uh, the flood won't happen again. Okay, so there are all kinds of common observations: the sky being blue, the rainbow going across the sky, uh, which can also be accommodated in this model by elaborating, adding details to the model um, with stories, right? Explaining how those features came to be. Yeah, rains from the sky. Well, we are not talking about normal rain because we can see rain falling from the clouds. We are talking about a once in a thousand years or whatever, once in a creation kind of event where there's a massive flood that wipes out literally everything. Everything just, all the landmass of the earth is kind of gone, right? That kind of deluge can only happen if the waters from here, like if this dome was, if there was a leak in the dome, right, and the entire flat earth is sort of submerged. From the point of view of a farmer, some shining objects which look like stars in the sky do not follow this celestial sphere. Yeah, so there are actually some objects in the sky which don't move synchronously with the stars. They seem to wander. And so the Greek actually called them as wanderers. The the Greek word for wanderer is planetes. So the planets, which include the sun, which include the moon, right? The moon also wanders relative to the stars. On one night, you might find the moon in front of one particular star. Then on the next night, you'll find the moon elsewhere in front of some other constellation. So the sun, the constellation behind the sun changes from season to season. Same thing for the moon. And same thing for these other bright points of light: Mercury, Venus, Mars, Jupiter, and Saturn, which you can see with your naked eyes. Okay, they are bright enough, they are brighter than the stars. You can see them with your naked eyes, and they also seem to wander. And so you have this notion of there being seven planets: the Sun, Moon, Mercury, Venus, Jupiter, uh, and Mars. Sorry, Mars, Jupiter, and Saturn, right? Mercury, Venus, Mars, Jupiter, and Saturn, five planets, plus the Sun and the Moon. All of them were called planets. The Babylonians actually had, thought of all seven of them as gods, and they assigned a day of worship for each of them in sequence. We still call Sunday as Sunday. Why? Because historically, it was the day devoted to the worship of the sun. Monday was the day of worship of the moon. Actually, if you look at the Hindi names, those still maintain the names of they reflect the names of the gods in Indian mythology. Right? Ravivar, Shanivar, Shani is Saturn. It was the day devoted to the worship of the Saturn god in, say, Mesopotamia. Right? Somvar, referring to the day of the moon. Mangalvar, referring to the day of Mars. Um, Budhvar, referring to the day of Mercury. Guruvar or Brihaspativar, referring to the name of, like, to the day for Jupiter. Um, Shukravar, referring to the day for Venus. And then Somvar, which was, sorry, not Somvar, Shanivar for Saturday. Saturday, actually, even the English word Saturday is the day for worshipping Saturn. Um, uh, right, Saturday, Sunday, and Monday, they still reflect the origins in the worship of Saturn, the sun, and the moon. The names for Tuesday, Wednesday, and Thursday, uh, and Friday are not very familiar because the gods that they are referring to are from Norse mythology. So it's a very complicated history. So, but the point is they are referring to the seven planets, right? So a 7 day week, there is nothing astronomically significant about a week having 7 days. It's just a coincidence that a week has 7 days because there are seven planets that we see wandering in the sky in a way that's not synchronous with that celestial sphere. If there were eight entities visible to us, we would have an 8 day week. But other things do have an astronomical significance, like a month. The word month comes from the word for moon. It reflects the time needed for the moon to go through all of its phases. From the full moon, the moon starts uh, waning, it becomes half moon, and then crescent moon, and then it's not seen at all, and then back to a crescent moon, again a half moon, the waxing phase, and then back to a full moon. Roughly, actually, not roughly, that is the definition of a month, the duration of time it takes for the moon to go through all the cycle. The definition of a day is obviously, you know, um, from one sunrise to the next sunrise, that is one day. Actually, in ancient times, a day was from sunrise to sunset, and then from sunset to sunrise, it was night. It was considered a separate uh, interval. And then a year also has significance because a year reflects the passage of all the seasons: summer, uh, fall, winter, spring. Actually, you can start from spring. So spring, summer, fall, and winter, and then back to the beginning of spring. Right? We can talk about that maybe later if anybody's interested. But how do you how do you identify the beginning of a year exactly? By looking at the night sky, um, um, or by looking at the position of sunrise, because the sun doesn't rise it rises from the east, but not exactly from the east every day. Uh, it actually moves around during the year. And so when it comes back to the exact same rising point, you can identify the exact completion of 1 year there. Or you can look at the night sky and other data from the night sky. So that's how calendars were built, by looking at these simple patterns in the night sky. And you can also understand why geometry was important, because see, you have circular motion happening in the night sky. And so uh, trying to come up with ways of um, capturing uniform circular motion was was natural, right? Um, okay, any should we stop here, Kapil, or are there any should I take questions?
I think we should stop. I have one question from you. I think most of the students or a lot of students might have that question.
Hmm,
Uh, they might be wondering,
hmm.
where does this lead to with respect to the normal coursework,
Right,
right?
right, right. So let me answer that. So
Yeah.
we have a flat Earth cosmology, right? The next major step, the next major leap that we're going to make is to move to a more sophisticated cosmology, which will, and see, this is like giving away the part of the who the murderer is before even going through the mystery. But since you asked for it, let me point out we are going to move towards a spherical Earth cosmology, where the Earth is at the center of the universe, and there's no ocean or anything under the Earth. There's empty space, right? And how all that can be established, how that can be justified, that is something we will look at. It will require us to understand a very sophisticated but commonsensical physics called Aristotle's physics, because Aristotle is the philosopher who developed that physics in its full-blown form. And that was actually the physics that was prevalent for 2000 years. That was the physics which had to be abandoned in favor of a new physics um, at the time of Galileo and Newton, because Galileo's observations of the night sky showed problems with that spherical Earth cosmology. See, astronomy is connected to physics. Whatever astronomy astronomical model or cosmological model you develop, it has to be supported by a physics. Like here, even in this simple flat Earth cosmology, you see that there's water under the Earth to support the Earth from falling down, right? Because commonsensical physics tells us that space has an absolute direction up and down, and things tend to fall down if they are made of earth and water or solid and liquid. So, in a similar way, Aristotle's physics also has to explain things, and it explains a lot more things than what we have seen so far. But if you replace the um, astronomy with a completely new astronomy where the Earth is moving and going around the sun, it just it, it just completely blows apart the physics, the old physics. It just doesn't make any sense. You can't just come up with some astronomical model which contradicts physics. So new physics has to be built, and that is the physics that is there in your class 11th mechanics, right? So that's the physics that we want to build up brick by brick. But to build up that physics brick by brick, there is one other uh, intermediate station we have to stop at, which is the spherical Earth cosmology of Aristotle. That will be a relatively long stop. It might take a full class. Uh, but it's important to understand that because that is what the new physics is meant to replace. And every single concept that you learn in that new physics, you will see that it is contradicting and replacing uh, a piece of the old physics. And Galileo and Newton were trying to build this new physics in a way that, see, it's like a jigsaw puzzle. आप लोगों ने jigsaw puzzle बनाया होगा 1000 pieces का, 2000 pieces का. All the different pieces of a jigsaw puzzle have to fit together to form a clear picture, right? So in Aristotle's physics, it's a jigsaw puzzle. Okay, very nicely the different pieces fit together. Newtonian physics is also a jigsaw puzzle. All the pieces fit together. How do you go from one jigsaw puzzle to another jigsaw puzzle? You cannot point out one or two problems with the old physics and say that I will replace them with some pieces of new shape, right? Imagine taking out two or three pieces from the old puzzle and putting in some new pieces with a different shape. That will completely mess up the picture, right? So that entire picture has to be replaced by a new picture. And that's what is called as a paradigm shift in science. So it's a momentous shift. It is probably the greatest event that has happened in human intellectual history in the last 500 years. Maybe, maybe in biology you can say that Darwinian revolution was one other such paradigm shift, but the Newtonian revolution is one of, if not the most, one of the most important events in human intellectual history. More important than, because it changed the way humans thought about themselves everywhere in the world sooner or later. So we want to understand that moment, why and how it was so momentous. Then you will see that, well, physics is, it's not just about some formulas. It's about completely changing the way I think about the world. Okay, so that's how we are heading. Is that okay, Kapil?
That's fantastic. I'm while you said that you are outing the murderer, for me the murderer is still not outed. So I guess it is going to get unraveled as we move along. So guys, any final word? Otherwise, we will stop here. We will
Yeah,
let you know when the next class is going to be, and there would be a way for us to communicate with you. We will continuously send you WhatsApp messages with the Zoom link, so you don't have to worry about whether you'll miss the class or not. And as you can see, I can see some pattern, but it is not completely clear to me. But I'm going to be attending these classes. I got through IIT by brute force of understanding, or rather doing the mechanics of physics, rather than developing any interest in it. I'm hoping that at age 45, I'll give it another shot. I have my kid who is age 14. He's trying to step into that world where it is easily possible that he would get bogged down by the mechanics of it, just the workings of it. So That's good. Thank you so much, Omkar. It was very good. I will coordinate with you, and we will communicate time for the next class to the students.
Yeah. Thank you. Thank you, everyone. Have a good night.
Excuse me, Mr. Omkar, can you actually take a single question?
Yeah,
I
yeah.
mean,
Go ahead.
so I had a concern regarding the development of interests, which you had mentioned in the earlier part of the course, that you had developed an interest later in physics and actually had a spontaneous interest in biology. So I had a
Yeah.
concern that how are you actually developing those interests? Is it consciously or unconsciously? And how are they different? How are they different? Like the
Yeah.
interest which you had developed for biology, that was spontaneous. You didn't
Right.
actually put in effort into that. But for example, you in physics you had to develop interest. The development part. I didn't
Yeah.
get
Yeah.
that development part actually.
Yeah, that's a great question. It's actually a very long story, but you're right that, in high school, my primary interest was biology. I was not that interested in physics and chemistry, and definitely I had an aversion to mathematics. So where I actually changed was during my years at Stanford, because Stanford is a liberal arts school. I don't know if you're familiar with the idea of liberal arts,
Oh
but
yes, yeah,
uh,
yeah, got
there
familiar.
is a lot of importance given to the humanities in a liberal arts school, because it's not just about career, right? It's not just about training to become a professional in some field. It's also about becoming a well-rounded citizen or a human being of, a citizen of this world. And so the humanities had a lot of importance, and I got very interested in philosophy for that reason. Because see, when you think about these big questions, there are lots of big questions that you might be curious about, and every human being in every culture, they ask these big questions. Now, how do you systematically try to pursue those big questions? Well, if you directly try to study some subject in its modern form, then it becomes hard to grapple with the complexity of that subject. But when you start from scratch, thinking from scratch, you realize that the people in ancient times were also thinking from scratch, and so they were thinking just like you. So when I started studying history, but again, from scratch during my Stanford years, I realized that I was actually making a lot of friends, right? The writings of people from the past seem to be, very friendly writings because they were thinking just like me. And so by uh, by focusing on the history, the lives of those people in the past, specifically the intellectuals who developed the science and math, I got more and more drawn to relearning and reinventing uh, the science and maths that I had learned during my high school years. So it was really during those Stanford years that I developed a deep interest in actually everything. The problem is during the PhD years, you're supposed to narrow down your focus to a very specific area of research. The opposite happened with me. My interest started broadening out and I became interested in literally everything. So it was very confusing in that sense that, what should I study? Because there's so many interesting things to study. So, um, so astronomy and mechanics is what I narrowed down eventually, because astronomy was the first science. When you look back at what was the very first uh, step that you can identify as science in the ancient world, it was in the context of astronomy, because in astronomy you see very clear patterns in the night sky which repeat. So you can come up with models to explain them, and as your data becomes more and more refined, you can keep refining your models. And astronomy directly gave birth to mechanics. And that's why I got interested in mechanics, because I saw how science originated in the ancient world in astronomy. I read the Greek philosophical writings, the ancient writings um, 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 from philosophers who came up with these different models. And then it was very nice in that I realized that it actually makes you feel good that speculation is not a bad thing. It's a bad thing in modern education because there is no time to cater to your individual speculations, right, or individual directions. But it's actually an important thing for innovation. And all these innovations that were happening through philosophers and scientists, I realized they were freely exploring, they were playing with ideas, and nobody was disciplining them, right? So, and these questions were important for them. They were important questions of life for them, um, because it impacted how they thought about their religious texts. How did it impact their belief in God? How did they have to change some of those core beliefs? Um a struggle to reconcile, for example, um, what, say, the church might say with what observations you are making, but you still want to remain a good Christian. How do you reform your ideas so that you don't give up your belief in God, but keeping that in preserved. Uh, you develop this new science. These were struggles that Galileo, Newton, and others were going through. It was from a humanities perspective, that was what was driving them. I don't know if that answers your question.
Oh, no, yeah, actually, it answers quite well. And I just wanted to shed some light on the playing part, actually. Like, for example, did you ever get frustrated while solving anything? Like, for example, physics is really, I mean, I should say, at a higher level, very tough, I would say.
Hmm.
So, by playing, did you even experience frustration or something
Yeah.
else?
So what I realized is that frustration is a normal part of the process of investigation and problem solving. I'll give you an analogy. When you solve exercises or problems in your school life, they are mainly exercises. They are repetitive. They are just by looking at the question, you're supposed to know what method to use. It's like exercising at a gym, right? There's no mystery there. These are the motions you have to do. They'll build your muscles for sure. You become faster and faster. You become stronger. Problem solving investigation of the kind that I'm talking about here, it's like hiking. It's like hiking an unknown terrain. Okay. Now, when you hike, you're going to get frustrated because you might find that your path is blocked, right? Maybe you're hiking without any trails. Your path might be blocked. You might run out of food. It might rain. You might get dirty, right? But the thing is, those frustrations are a natural part of exploration. If you want to be an explorer, then you have to, treat those frustrations not as a bug, but a feature of hiking. So at the end of the day, you are able to climb on top of the mountain peak, which was your original goal, you look back, the hike is immensely satisfying, right? As a whole, the frustrations that you encountered on the way is what makes the final achievement even more relishable. And um, without the dead ends, without the frustrations along the way, you would not have been able to figure out what the right path is to get to the top. It's not like you see the path to reach the top from your starting point at the bottom. Right? That path might be invisible. Even in a physical sense, the hiking trail that leads to the top of a mountain peak may not even be visible from the bottom of the mountain. You might have to follow a different trail. You might encounter forks, and you might follow some of those forks, reach dead ends, then backtrack, and then follow a sequence of trails until you see the final trail that leads to the top. So that is the way science proceeds. It's not like, you see the problem and you immediately figure out a way to get to the top. That's not how it works in real life, which is why the exam oriented preparation is quite different from the way research is done in science.
Excuse me, sir.
Yeah.
Sure.
I want to ask you a simple question that when you are for your for exam, how curious you are. Mean that
Your
you are
voice
on
is
this
breaking. I'm not able to make out your words. Could you maybe speak a little slower so that I can make out?
I am asking that how curious you are for your life. Write the
No, sorry, I
to
still
your
couldn't hear. Maybe you
web
could
now.
just type your question. Can you just type your question in the chat box? Uh,
Sir.
Um, Sorry, I'll just answer. I know you guys have been asking a lot of questions, but unfortunately, I'm not able to follow all of them. Let me just quickly. How does
Sir,
your
sir, I
yeah,
had
go
a
ahead.
question.
Hmm.
Would you agree on this fact that solving problems and speculations about the basic criterion that physics follows are two different, like two
Mm-hmm.
different, very different fields?
Right,
Because in terms of mastering the problem solving techniques, we can't just sit back and speculate things because
right, right.
one is a constraint factor for us giving the entrance examinations, and also it plays a huge role in mastering out the fluency, as I said earlier.
Hmm.
So, how to tackle this curiosity, but as well as the mastering of a concept through problem solving? What is your viewpoint on?
So the key is to allocate more time, right? Which is why I said that if you're short of time, then this might not be an option for you right now. If you have more time or if you start earlier, then you can devote more time to this way of learning so that this is the way you understand the theory, the concepts, and then you switch to a different mode when preparing for the exam, right? Now when you understand how Newtonian physics is built, you will never be confused about the concepts, but you will still have work to do in how to apply them to the problems that are being asked in the exam. So that is something that I consider to be phase two of your preparation, right? Phase one should happen ideally early in high school, and you can obviously mix them up. But as you get closer and closer to the exam, that phase two, where you are trying to develop fluency on what's needed for the exam, that is more and more important. So that's why when you do last minute prep, it doesn't help you develop an interest in the subject because you don't really have the bandwidth to develop an interest.
The exam oriented approach is quite a bit narrower than the speculations, because that's just basic repetitions of patterns and maybe the
Yeah,
way they are.
yeah, yeah, that's true. It's required. I mean, you can't avoid it. I mean, I have my own son is in high school, which is also part of the reason keep up with this because I don't want him to get crushed, lose his interest. Um so as a parent also, I fully understand that the system is not set up in the right way. And I have full sympathy for students because a lot of the issues that happen are because of the system, right? The fact that how do you build an education system that can educate the mass of kids uh, in the basic skills um, when nurturing curiosity seems to require a lot of one-on-one attention and a lot of conversation and debates, right? Arguments.
Yes.
Um, so that is the tension, which is why you don't have an ideal education anywhere in the world actually. So, how somebody asked how curious was I when I was preparing for IIT, or was I doing only exam-oriented study? No, I was not doing only exam-oriented study. So, like I said, I got interested in bird watching, which expanded into an interest in ecology, which expanded into an interest in evolution, which expanded into an interest in, uh, botany and many of those other topics. The thing that I did not get interested in was anatomy and physiology because I knew I didn't want to be a doctor. So, but the rest of biology really fascinated me, and I used to study biology as a means of relaxing because of that interest, right? Because I would go out, see new birds in the world, I would try to understand what habitats they live in. It was like a discovery for me. No adult was teaching me how, which bird am I looking at. Um, I was making those discoveries on my own, and in fact, I saw that the adults around me didn't have any knowledge of birds. So it felt like I was discovering and figuring things out on my own. And that feeling is what became the fuel for me to study biology. Now, when I took on physics, chemistry, the study of physics and chemistry, I used to try to make connections to biology to make those interesting. So, just as an example, in physics, there were some textbooks by US authors I saw where the problems at the back of the chapters were drawn from biology. Like, for example, instead of finding tension in a rope, when there are a bunch of blocks connecting, connected by a bunch of ropes, some of those questions were about how much, if you lift a weight in this particular way, how much tension will there be in this particular muscle? So it was in the context of um, biology that some of those questions were asked, and that actually helped me to I felt that okay, there is some connection between physics and biology. Chemistry and biology, of course, there is a connection, because that biochemistry is where they intersect, and once you get into genetics and molecular biology, then a lot of what's happening in molecular biology, as the name itself indicates, is essentially chemistry, right? Chemistry, but having an impact on complexity at the next level, which is at the biological level. So, um, yeah, and then once I got interested in this whole question of human origins, then I got interested in the humanities as well, because fields like archaeology, anthropology, and of course those were not part of the IIT entrance exam, but I don't know if that answers the question for now. I wish somebody had taught me physics in the way that I am trying to teach right now. That would have made it a lot more interesting. But the best I could do during my 11th and 12th grade that time was to, understand that, yeah, there is, you can apply the physics that you're learning even to problems that are coming uh, from biology.
Sir, am I audible?
Yeah.
Yeah, I just wanted to ask one basic question. That is, right now, given the current advancement of science and all the tools which we have got, which we use to make new research and make new inventions, back then in 1500s or 1600s, in case of biology, if we see Charles Darwin, in case of physics also and chemistry also, the path which was in front of them before they ultimately arrived to some sort of conclusion or invention, it was not a path which actually had an end goal, right? Like right now, if we are sort of doing an invention, we sort of have in mind that this is what we are walking towards.
Right.
Back then, they didn't have anything in mind that this is the end goal. So, what could have been the real mindset which actually helped them and kept them motivated to continue their work tirelessly and arrive at a conclusion?
Yeah, so like I said, science was not a profession back then. They were not paid for it. Now science is a profession. So any research that you do, you need to have an end goal in mind. Otherwise, you won't get the funding also when you propose to do any research. Back then, they were doing science as amateurs, as amateur hobbyists who, but they had big questions in mind. Okay, the smaller questions in physics or chemistry or whatever it was they were dealing with was uh, significant for them because they connected to that big question in some way, right? And that is what gave them uh, significance.
Sir, what is your views on theory of special creation as you are talking about the origin of Earth? So, is there any significance of God?
Is there any significance of God? So again, like the question then becomes, what do we mean by God, right? Because the word God has very different meanings for different people. The descriptions of God or gods that you find in one particular text, for example, may not be how you want to think of God, right? And that is the kind of struggle that you find with Galileo, Newton, and others also, because for them, the God of the Bible who created the universe as described in the Bible is the same God who also created the universe. And so the evidence that you get from the universe, which Galileo called the book of nature, if you remember the slide I showed you, the book of nature and the book of scripture for him had the same author. And so they have to be made consistent with each other, right? So the thing is, the book of nature is giving you the direct evidence. So if the book of scripture contradicts it, there are two approaches. One is to reject the book of scripture. The other is to reinterpret the book of scripture, right? So depending on how committed one is to a religion, one might uh, either reinterpret it or reject it, or one might reject science itself, right? So there are these three broad approaches. In my case, I tended to, I am, if you ask for my personal beliefs, I consider myself to be still on that journey to discover the ultimate truth. Once you consider yourself to be a hiker, right? I'm not at the peak yet. I don't know what is, at the root of all existence. It could be a god, uh, but it is likely, in my opinion, it is not likely to be the simplistic kind of god whose understanding we get from popular um, presentations of religion, right? Which are y- which are often not consistent with what um, you might learn from this journey of learning science. And so one has to keep refining, adopting, changing one's views about ultimate reality if one wants to follow this path. So uh, so that for that reason, in short, I neither accept God in the sense that uh, popular presentations talk about it, but I also don't reject God, uh, again, in the sense that popular presentations might talk about it. For me, it's an open-ended question, and I'm still on that journey to understand. I mean, I have some basic, I feel like there's something fundamental about consciousness in the universe. And that's what makes me open to learning from many of the ancient religious texts. But it's like, for me, religious texts are like, when miners go into a mine, right, to find gold, you're never going to find gold in its pure form. You will always find an ore, right? An ore which will be black, lot of impurities, and you have to really work a lot to extract a much smaller piece of gold from a much, larger volume of ore. So, so that's how I look at, the ancient texts. I think there is definitely gold to be found in many of those texts, but one has to work a lot more to extract it rather than, you know, like it's not pure gold, right? There are a lot of conflicts between religion and science, so it's difficult to consider these texts as infallible in their entirety. But at the same time, uh, given their influence on the course of human history, given their impact, one does find powerful ideas in them, which definitely should be taken seriously. And so it's also, I think, immature to just say that all, all the ancient texts are useless. So that's a more nuanced view. I don't know if that
Several
answers
some
your question.
philosophers believes that when the ancient people are not able to explain the reason of the laws of nature, they relate these all things with God.
Sorry, I couldn't follow your question. You asked a question or a comment?
Sir, when the ancient people are not able to explain the reasons of the laws of nature, they relate these things with only God, and after that, they will never give any explanation on that.
Yeah, so when you see things happening in your life, right? I mean, there are obviously bad things that happen all the time, freak events, accidents. There's a lot of suffering in the world. So, what can you do if you don't have like a tangible uh, cure for that suffering, right? You have to accept it in some way. And so, um, how do you get to accept uh, things in the world when, there are unfair, like I said, a lot of unfair things that you see happening. So you need a larger picture to make sense of it. And that's what human cultures have come up with. They've come up with stories. Some of them might be grounded in historical reality, others might not be. But at some level, humans are trying to make sense of the world around them. And yeah, I mean, the the stories of God or the gods provide a way for humans to feel secure in a world that is inherently uncertain. And we could say the same thing about science too, that the science that is um say 500 years from now, we might look back at the science of today and say that, well, that was how people made sense of the world in that time. And so the key here is not to be attached to any particular view, but to be on that journey in an open-minded, honest way. Because in my opinion, and this is something that Galileo also firmly believed, that if you are true, if you're honest about being on that journey, about looking at the evidence, like why would any kind of God want you to hang your intelligence and not go by whatever evidence you see in front of you? Uh, so I don't think that one would be punished for um for pursuing knowledge in this particular way. I think this is actually the only way to pursue knowledge. Otherwise, you just end up with believing whatever family tradition you're born in, right? Whatever religion you're born in, which is, basically an accident. And that approach might work in a world when communities are isolated, as they were in the ancient world. People did not interact much with one another except traders, maybe. And so everyone could have the same set of beliefs. But once people started moving to cities and interacting with people from other cultures, then they started realizing that their answers to the fundamental questions are totally different from my answers. So that is what sparked philosophy. The birth of philosophy was sparked by this observation that there can be other answers to these questions, and there are other answers. And so that sparks out this self-reflection. Why, how do I know that my answers are the right answers and not theirs? So you need to come up with a more objective criterion then, which is what leads to the development of logic, the tools of logical reasoning, which which are more objective, right? And then following where the reasoning takes you, rather than letting your emotions or attachments uh, lead you. Okay, all right.
Yes.
Uh, let's see, is there somebody else?
Thank you, sir, for this wonderful class.
Sure, yeah, this is good to take this. Somebody asked, how does curiosity help in a practical world where we have to finish a chapter in limited time frame? See, in the short term, you have to do what you have to do if time is limited. I'm talking about a longer term thing. See, it's like the difference between doing a surgery and focusing on nutrition. If your health is already bad, then surgery might be the only way forward, right? Given that time is short. But if you, in the future, right, your education does not end with one exam anyway. In the future, you have to focus on a good diet, right? Nutrition, exercise, if you want to be healthy. And I'm talking about educational health here, right? And this is the way to be healthy as you embark on a long educational journey, to approach things in the right way so that you don't get crushed or burdened by lesser things. Mm, all right, thank you for your comments. What should we do to crack competitive exam? Obviously, the answer depends on how far the exam is. So I would say if it's short term, and by short term I mean maybe within the next year or two, and you don't have time, then you should try to find a teacher who you resonate with, and you know follow what they say, but do not always keep this in the back of your mind that if you don't understand something, it is not you. And even if the teacher or someone else makes you feel that you're uh, uh, less intelligent student or there's something wrong with you, always remember how long it has taken humanity to develop these ideas. It has taken thousands of years. So if you keep that perspective in mind, don't lose your self-confidence in yourself, even if you're not able to perform in an exam because you may not have the time to prepare, or maybe you didn't learn things in the right way. So that's just, an exam is just a test of where you are right now, right? It's not a test of your potential, your true potential. It's not a test of where you could be if you were given, say, a year or two more. So uh, if you as long as you keep that perspective in mind, you can block out all that noise from the world around you, you know, trying to judge you all the time. And if you follow this more nutrition based approach, you will develop that self confidence in yourself, and you won't need others to validate it for you. Because once it comes from within, like it came from me when I was doing bird watching, or as I was restudying all these areas. um, you know, the validation is coming from within myself. I know I'm getting better. I know I've done well. So it's not something dependent on others. And this actually increases your probability of doing well, even objectively.
So I had two questions regarding the schedule of the classes and the timings also. So when will the classes be held?
Uh, Probably a similar time, either Saturday morning or Saturday evening, India time. Um, yeah, because I
So sir,
also yeah.
sir, will it be will the classes be held every week, or was it just for now?
Uh, it is every week. Yeah. The plan is to have it every week unless like I'm busy or something happens. But on average, the plan is to have it every week.
And so the thing regarding the recordings. So where will we be getting the
Yeah, so
recordings?
that is something Kapil will tell you. Um, I'm not associated with NEET prep. I mean, Kapil is a friend, of course, but this is something we are trying out as an experiment. And if this works well with students, then somebody asked, will you be teaching all of physics? Well, it just depends on how, what kind of feedback you give and how you find this. If we feel like this is working out, if students are liking it, then we might cover more and more topics and keep extending this. Somebody said curiosity doesn't help us survive in the real world. Like we need money to survive. Of course, Ria, you're absolutely right. Uh, but curiosity is what can keep you going, right? Even in bad times, because there will be a lot of ups and downs in life. Even as you try to earn money or crack exams or whatever, there will be failures. A lot of failures you will encounter, and so the the thing is, if you are completely attached to those material metrics for success, then you can get badly hit by mental health issues in those times. Um One of my roommates actually my roommate at Stanford was the topper from IIT Bombay, and I saw him descend into medical depression. You would imagine that, with that kind of achievement, there should be no reason to feel depressed. But you know, the fact is that, the more the better the university you get into, or the more you achieve, you get surrounded by peers who are also like you, and so you always have this feeling that I'm not good enough, right? Even if you are objectively very good compared to, say, an average person from the population. So uh, unless like you have something else like curiosity and, something more meaningful from the experience, when when things get tough, right, and when you encounter failures, you may not develop that resilience to overcome them. And it is things like curiosity and all which keep you going even in those times. So I'm not saying that curiosity is the only thing you need to survive in this world. You definitely need to do a lot of other things, practical things to earn money. Um, but it is an important ingredient to add to your life uh, in the long run. That's my point. where is my hometown in India? Well, I was raised in Delhi, uh, on the IIT Delhi campus, actually. My father was a professor. My parents' hometown was in Pune and Belgaum, so Maharashtra, Karnataka border region. Uh, yeah. Um and I currently live in Silicon Valley in California. How do you define an efficient break or rest? I'm not sure what you mean by efficient break or rest, but there is this technique called the Pomodoro technique. You might just look it up. You can always break up your study into a series of 25-minute intense sessions followed by a 5-minute break, like that. And then every once in a while, you have a longer break. So just look at the Pomodoro technique.
Also, I had a question regarding your scientific intelligence and intellect. Also, like you had said that you developed a very keen interest in philosophy. So I would like to ask you a question that why do we even get attached? Like you mentioned your roommates incidents, and I was a bit curious. So why do we even get attached?
Why do we get attached to what?
Anything. I would say anything. A person, a subject, you could say, and anything I would say. And if that attachment is taken away from you, you get angry, you get, I don't know, many negative emotions, I would say. So why do we even get attached, I would say?
I think when we get pleasure or happiness from something, we naturally want it to continue as long as possible. And the nature of things is that you know things are always in a flux. So uh, whatever you might be attached to, the chances are very high that they will get taken away or at some point, right? Just nature following its course. And so if we depend, if we invest entirely on something that will be taken away from us, then it's a recipe for future misery.
Uh,
But if we get attached to something that cannot be taken away from us, then it's a more stable kind of attachment. So Ptolemy, one of the astronomers who, maybe I'll just mention him later after Aristotle's physics, he has this famous quote. He says that um, when I look up at the night sky and I immerse myself in the close revolving spirals of stars, referring to the circular motions. And he says, my feet no longer, no, sorry, he starts out by saying, I know that my life is marked for death. But when I look up at the close revolving spirals of stars, then my feet are no longer touching the earth. I take my share of uh, nectar, um, no, something like that. Uh, like I feel myself in touch with Zeus himself, and you know, I drink my share of immortality. So, in his study of astronomy, he was, he felt like he was actually in touch with something eternal, something that transcends life and death, and arguably, the laws of nature, the the fundamental laws underlying the universe, either in an impersonal or personal form, um, um, are things that cannot be taken away from you. And so, um, yeah, so about teaching the whole of physics, obviously I'm open to it, but it depends on your feedback and how much time you have, because the downside, the practical downside of this approach is it needs a lot of time, because you need to understand a lot of backstories and background context to make sense of the ideas which are being presented without any context in your syllabus, and they are pretty complex ideas. uh, yeah. How do you get into philosophy? I think my interest was sparked initially at IIT and then at Stanford. When you encounter people with very different beliefs who are very different from you, uh, you you will you will get interested, is what I feel. And you find an environment which nurtures that curiosity. one thing that helped at Stanford was I was not dependent on any professor for funding. I got a fellowship from the university directly, which allowed me to do whatever I wanted for 5, 6 years. And so I used that opportunity to explore and do what I study, what I liked. And when you get freedom, academic freedom, it does help you do things that give you inherent uh, enjoyment. Give me a list of philosophers, or I think you should study all of world philosophy. So you can study books on. There's no single book that I can recommend, but people have written about the history of philosophy. There are number of books, but it requires a lot of effort. Requires a lot of effort and time. I would not recommend it at your stage if you are preparing for exams. You should focus on what is practically helpful if time is limited. But in the long run, uh, whichever college you go to, there might be humanities courses, so you could take those. Any comment on Bhagavad Gita? Yeah, I've read Bhagavad Gita. Definitely, found it helpful. Um, um, yeah, I think a study of world religions in general, um, and world philosophies in general is helpful, because there are always good things you would find from every culture, right? And definitely Bhagavad Gita, like I said, and that's where I started, because I was coming from a standpoint of studying first the text in my own culture, and then also the only thing is, you should just be a little careful about uh, uh, judging other people, other cultures, based on your own. So that's where it's important to keep your mind open and y- study viewpoints that are also quite different from from the viewpoints of your own culture, uh, and keep in touch with people who are who have very different beliefs, uh, and the same mindset, right? And important, the same mindset as you. Then you will feel yourself making a lot of progress, taking value, good things from everywhere. Okay. All right, I'll stop here, and yeah, we'll we'll continue. I think Kapil will get back to you.
Thank you so much, sir. Thank you very much, sir. I love you, sir.
Thank you, sir.
Thank you. Thanks.